it's a famous place in DC for a convention. Yep.
Yeah, exactly. All right, so we're gonna get started. We're running a minute late already. Hello, everyone. Welcome to the Aerospace and Defense Showcase. My name is Osher Rudensky. I will be the moderator, so to speak, for this event. I am also the managing director of Deep Tech Showcase. So we begin. So today's agenda is opening remarks and meet the panel. That's what's happening right now. After that are the presentations. We decided for this event that this sessions made more sense just to do 3 sessions with every company being relevant for aerospace and defense, because there was a blur, meaning to break it down, one into aerospace, one into defense, didn't do the companies justice necessarily, so we combined them. So all of the companies you are seeing have a defense and or aerospace use case. A lot of the times it's more of an and than an or. And the vision for Deep Tech Showcase is to help companies bring their tech to market. Everyone who has spoken with me in the past, which is a lot of folks on this call, know that a lot of the time founders have fantastic ideas. Where the problem lies many of the times are in finding the right people at the right times to connect the tech to champions of that technology, people who will move it forward and get it through and get it into the right hands. So we're trying to get more deep tech into the right hands so that the world will be a better place for everyone. And even though this showcases aerospace and defense, the goal is in general, any technology that can make people's lives better is something that is very important. So as I'm going to repeat myself slightly. So we created this ecosystem. The ecosystems are filled with startups, and those are the founders working on the technologies, developing them, bringing them to market. Tech scouts. These tech scouts could be either government and or corporate. And a lot of the time, the government scouts are work with the corporate scouts and vice versa. There's not a lot of the time the lines blur. And then lastly, investors. And I think everyone understands where they come in. And anchoring these events, anchoring the showcase and the ecosystem are these events that you guys are at. We have a monthly event, and this month is aerospace and defense. And next month is going to be IoT, edge, cloud, and cyber. Then after that is going to be energy and clean tech. Following the events, we're not here just to throw the event and say, hey, you saw a company, great, fantastic. Now you could go back to your office and never think about them again. Our goal is to connect the companies to the stakeholders. So after the events and in between events, we usually send company profiles to stakeholders with the goal of forwarding the connections and having the connections actually happen. We want there to be real movement for both sides, because that's where the real value lies. If anyone in the audience who's watching would like to be connected with a company that you see here today, feel free to message me. I'm going to post my email in the chat. You'll see it. You can respond to me. And also, I'm very active on LinkedIn. You can reach out to me there as well. So without further ado, if Joe is on the call, I want...
I am.
Perfect. Hi, howdy. How's it going?
I'm good.
Good. Fantastic. So I'm going to let you share on your end, if that's okay with you.
Yeah, all right.
Joe is going to introduce our sister company very briefly, Eagle Point Funding.
All right. So very briefly, I'm Joe. I'm the Director of Business Development at Eagle Point Funding. By far the least interesting person on this presentation today, so I want to make it extremely short. I'm going to talk about what we help in non-dilutive funding, and I see a bunch of familiar faces in companies that I know personally that are going to be pitching. So I'm definitely excited because I have this very much, I want my companies to succeed and grow, not just on the non-dilutive side that we help with, but also get investment in sales, which is what we do with Usher's team. Because slides are more interesting than just me talking, I'll share the screen because Usher asked me to. So here, if people can see the screen, it's just going to be 35 pages and take 30 minutes. No, I'm just joking. I want to make it straight to the point and let everybody else present. We're Eagle Point. We help you with grants and government contracts, specifically in R&D funding. And our goal with the company is help you raise $750 to $1.6 million in the first 18 months of working with us or less. And the or less is on a high emphasis, and we're definitely reaching that goal from companies we saw just in the last 3 weeks. And we want to aim at $10 to $30 million during the whole time that we'd be working together. These are just a small part of the agencies that are open now and closed by March. And you can see the National Science Foundation that is open, Department of Energy, Department of Defense, NASA, and AFWERX from the Air Force, which are here. So they also know that they're open, I hope. Non-dilutive funding is cool, not just for the dollar amount. It's because the Department of Energy saw that when you win an award, you double your chances of getting follow-on private sector investments. So never look at the grants just as the value of the actual award, but what it helps in the entire strategy of the company. You don't have to work with us, but don't knock it off just because you've heard some people talking about it in the past. Review it specifically for your company, especially now. The results on working with us, we do multi-submissions, but you don't really care about that today. What I want you to know is companies that work with us over 9 months, around 50 to 60%, about 2 out of 3 win at least one award in the first 9 months, and 100%. All of my companies that I vet will make anywhere from $450,000 to around $5 million. This is the number that I need to update. The way we envision that is you do non-dilutive funding, you win, you do the aggressive PR as you've felt Eagle Point knows how to do in our email and LinkedIn campaigns. After you let the investors and stakeholders know, you also let potential clients or people that are going to do pilot contract with you know that you're doing this. So even if you're not going to have to use them in the next 6 months to 12 months, but when you actually do need them to pull the trigger and trust you and experiment with you or invest in you, they are ready, they know you, and they trusted you. So the non-dilutive funding is the first domino stone that tumbles that helps solve kind of the chicken egg problem of fundraising. What we guarantee on clients that are working with us is a minimum of 2x ROI on working with us for 18 months. I'm not going to talk about money, even though this is a fundraising kind of event, but there's essentially when we have a 100% success rate over 18 months, we commit in the contract that you'll make at least 2x ROI. Statistically and historically, none of my companies has made less than 7x, and some have made like 150x. There's a minimum commitment, but after that, pay as you go. And these are testimonials. One person here in the audience should recognize their face here, and expect me and Asher's team to aggressively go after non-dilutive funding, seed to Series A, biz dev training, aggressive media and investment network hunting team, and dedicated funding efforts, stuff like StratFi, TACFi, or helping you find MOUs, etc. That's me. That's a horrible phony that I absolutely hate. And the QR code here on the right is available to scan. But Asher has our details, and we've been around the block. So that's it. I really look forward working with the companies here, because working and doing both the fundraising and connecting the community and doing non-dilutive funding, definitely we've seen that makes companies really resilient. So if you have to decide between working with Asher's team or me, because I'm a guest, I'll say work with Asher. But if the option allows, I definitely say work with both of us. The people in the companies that are pitching, and some of us have been working with us for a while, can vouch for our results. And that's it. I don't want to take too much of your time. I want everybody to have a great event. Let's get some smiles, even though this is we're supposed to be serious. And that's it. I hope everybody has fun, and let's rock on. Thanks, Asher.
Awesome. Thank you, or Joe. Thank you for that. So without further ado, I'm going to just quickly run through the sessions. For the first session, actually, I'm going to run through the first session, and then as we get to the next sessions, we'll go through those as they come. Session 1, we're in the middle of the opening presentation and the meet the panel. After that, we are going to have Monarch present, followed by Summer Robotics, followed by Amalgamated Vision. And for the panel for session 1, I'm going to quickly, sorry guys, I think the quality of this slide is a little bit of a potato slide, so you'll have to excuse me. But hopefully the panelists have their video on, so the pictures here that are, you know, very, very blurry will not be relevant anyway, because you'll be able to see them live. So from the U.S. Space Force, we have Dan Crouch. Dan, you want to quickly just introduce yourself and say hello?
Hey, good morning, good afternoon. It's still the same cheesy smile that I have on your screen, but yeah, I work for the U.S. Space Force, Space Systems Command, and at the Innovation and Prototyping Delta at Kirtland Air Force Base. So what we do is one of the things that's really important probably to this team and to what Joe just said is we have what we call the SSC, the Space Systems Command front door. And what we try to do is take those technologies that are out there from, you know, disadvantaged organizations, not the big ones necessarily, but the up and comers, and try to make contact with the right program offices at Space Systems Command to see what kind of technologies or systems that you might be able to bring to the team. So we're the facilitators of that. We just kicked this off a little less than a year ago, and looking to see what we can bring to the fight across the Space Force.
Absolutely. Thank you so much, Dan. And by the way, a few of the folks that I've worked with have used the front door with good results. So we really do appreciate the effort, and we feel it. It's great.
Oh yeah, and then I'll go ahead and post the website in there too, just so everybody has it. I don't have to repeat myself too much, but you guys will have that. All right, thank you.
Fantastic. Thank you, Dan. All right, next up we have Dan Madden from Squadra Ventures. If Dan's on the call.
Yeah, hey guys. Yes, Dan Madden, the National Security Lead at Squadra Ventures. We're a VC firm that focuses on seed stage national security and cybersecurity startups. My own background, served in the Marines, worked on the Hill, worked at the RAND Corporation, a think tank, doing research essentially for the Department of Defense. Spent some time up in Office of Secretary of Defense, the National Security Innovation Network, and then joined Squadra a little over a year ago. Thanks.
Awesome. Thank you, Dan. Next up, we have Han Ko from the USACO Group.
Hello, everyone. Han Ko here. I'm the founder and president of USACO Group. We are an international venture capital company. We actively search and invest in companies. What's unique about our company is that we have an international effort and then a base. So we have office in, of course, in USA, but we have office all the way in South Korea, Seoul as well. So, and we're very active in a global stage, so that we work closely with the European and Israeli, of course, market as well. So I'm looking forward to working with you. And one good thing about a Deep Tech Showcase is that I found I'm engaged in over a year now, and every time when I come here, it's an amazing platform. So I'll let you see that and be judge of that. Thanks so much. Bye.
Perfect. Thank you, Han.
Yeah.
Bennett, I don't think I see Bennett on the call. If you are on the call, feel free to raise your hand and we'll come back to you. Not seeing. Ridge, you're up.
All right. I'm Ridge Flick. I'm a major in the Air Force, although today I'm on leave so that I could do the tech showcase. So I'll be Mr. Flick. I go by Kelso. My background, I flew the most technologically advanced airplane in the world, the A-10C ground attack. Little joke there for those that are in the know. But I've got some experience working cyber projects, MOUs, and trying to connect companies to the right people in the Air Force. So I don't have any purse strings. I don't have any actual job that makes this applicable for me right now, other than I can try to help you find the right folks inside of the military.
And we definitely appreciate that. Thank you, Kelso. All right, next up we have Peter Ruiz.
Hello, can you hear me?
Yep.
Okay, perfect. Peter Ruiz. I work for Invest Puerto Rico. I'm actually based. I split time between the Southern California area and Puerto Rico, but my role is a business development director. I help bring in companies that want to set up in Puerto Rico, whether they want to do it for onshoring reasons, because we are part of the U.S. People kind of forget that, a little bit cheaper, considered Latin America, but still part of the US. So for ITAR considerations, if you're in biosciences, it's FDA considerations. We do have some funding. It's not directly through us, it's not through the government, but we set up a platform called Impeller, and I can share it on a link through the chat. It kind of connects everyone from the big corporate venture capital firms to smaller family office investors with companies that are looking to set up in Puerto Rico. So we kind of do a little matchmaking. Don't really do anything else. We don't take a cut of or equity or anything. Just kind of let the people matchmake and then set up facilities in Puerto Rico. We have a ton of aerospace and defense, just because a lot of the DoD work that's done down there. Honeywell Aerospace moved their entire North America R&D facility in there. We have Lufthansa and other people. So if you're interested, feel free to shoot me an email. I'll put my contact in the chat as well.
Absolutely. Thank you so much. Yeah, I'm sure a few people would be interested in connecting over that. Noah Feingold from Stellar Ventures. You're up.
Hey everyone, I'm over at Stellar Ventures. We're an early stage space and aerospace VC. We do adjacent stuff like transportation, mobility, defense as well. Our claim to fame really is we're pretty closely tied to Stellar Solutions, the aerospace embedded systems engineering consulting firm. Kind of lets us support our companies in a unique way and also diligence and find cool opportunities.
Awesome. Thank you so much, Noah. Next up, we have Corey Anderson.
Hey, Asher. Thank you for allowing me to come back on as a panelist. This has been a great opportunity. My background is I recently retired out of the 160th Special Operations Aviation Regiment, where we modified aircraft to support special operations needs. I currently work as a CETA contractor for the U.S. Army ISR Task Force, and what that is the intelligence, surveillance, and reconnaissance from both air and ground. And today we'll be looking at various technologies to see if it helps fill any strategic capability gaps in aerial reconnaissance, as well as, potentially how the data architecture and the processing on board the platforms may help that along. So I look forward to your briefings. Thank you.
Absolutely. Thank you so much, Corey. Next up, we have Sarah Pearson from the DIU.
All right. Hey, everybody. Good morning. Good afternoon. I'm Sarah Pearson. I lead our commercial team for artificial intelligence here at DIU. For folks that are not familiar with Defense Innovation Unit, we are focused on scaling commercial tech. So I'm here today to learn about awesome technology and see if it matches up with some of the needs and the demand signals we're seeing across the DoD and the IC. Thanks for having me.
Perfect. Thank you for joining us, Sarah. Next up is Joseph Blayout, but I'm not sure if I see him here. Joseph, are you on? Not a problem. All right. Let's make sure. And after him, we have Ian Pierce, but also I'm not seeing him here. But if you guys are not on the panel and you're in the audience, feel free to raise your hand and we'll try to promote you and we'll come back around here. So don't worry there. Next up, we have Sophia, who I'm also not seeing. And then after that, we have Andrew. Andrew Boudet, you're up.
Hey everybody, thank you Asher for having me as a panelist again. I'm part of Headquarters Air Force Futures, so we build a lot of the requirement that feeds the vision and kind of projecting out, the future force concepts and being able to kind of build the requirement that feeds really the budgetary decisions that go into Congress. So thank you for having me.
Thank you for joining. Next up, we have Martina. Zamoska. Martina, are you with us?
Sorry, I was muted. Hi. I noticed in the email description, the email chains that you had, it said NASA International Local Lead. I kind of need to fix that. I'm sorry, sometimes people shorten it. I am the local lead of the NASA Space Ups Challenge. So I run it off of NASA Ames Research Center and NASA Glenn Research Center. And the community comes and creates solutions that are later on pitched in the industry and the agency and the community. So in that field, we have a lot of investors coming in, business angels, VCs as well. And because of this showcase, actually, we found a path forward with Monarch. So I'm collaborating with them, and I am glad that that happened. So I just, had to mention that.
That's awesome. Happy to hear and happy to have you.
Yeah, happy to be here too.
Perfect. Next up, we have Rudy Besa.
Hey, thanks, Asher. First time on this event. Thank you for Ian Pierce, who's not present at this time. He's currently in going through training, so do apologize for his absence today. Part of Edwards Air Force Base, and we have an extensive background in aircraft testing. So a lot of the stuff that gets fielded, it comes to Edwards for aircraft to test everything that before it gets fielding, right? The one thing you want to do is you want to make sure that it is safe, viable, and it doesn't cause harm to.
Yeah.
What was that?
Sounded like
Can
someone.
you guys still hear me?
Yeah, we can.
Okay.
Still...
Okay. So again, aircraft maintenance, logistics test and evaluation. Also part of the organizational design office, so heavily vested into the innovation process ecosystem. It's vastly large, and one of the big things that we like to do is connect the industry with DoD, and even DoD themselves don't understand how big the acquisition cycle is. Once you get past the SIVers and the CIVs, all the small stuff, because when you get to the Pentagon, you hear things like the dust money. And so right now, my team's currently working in the AR/VR realm. XR, extended reality, you probably heard of that. It's been flown around for the past several years. We've been close touch with the leadership up in Pentagon to drive policy to really bring new innovations such as XR to the warfighter. So I think that's a little bit about me. Over.
Perfect. Thank you so much, Rudy. Thank you for joining. Joseph Lehut, if you can hear us, not sure if you can, but we're circling back around to you. You want to quickly introduce yourself? You're muted. Yep.
All right. Yes, I'm Joseph Lehut. I'm actually at Luke Air Force Base, Arizona. I am the F-35 Wing Avionics Manager. I pretty much help manage the F-35 program, and I'm definitely looking forward to any, future capabilities. I'm also in artificial intelligence at MIT right now, working with future leadership to human integration with artificial intelligence. So kind of looking to see what kind of AI capabilities or stuff that we can utilize here at Luke Air Force Base, and obviously with the F-35 program as well. And then also we all got a project just recently awarded and funded for AI drone like FODBOS tool delivery. So working with that. So just seeing what we got here for the panel, and thank you for the opportunity, Asher. I appreciate it.
Absolutely. We appreciate you joining. And then last but not least, we have Steve Elephant.
Elephant, but that was close. Thank you very much, Asher, and thanks for inviting me today. I'm joining you from beautiful sunny Palm Springs. I'm the managing director of Soaring Ventures. We're a venture capital fund that's trying to fill the middle market, working with Series A companies who have a minimum viable product and show the dogs eating the dog food. We have a little bit different background. My partner and I are serial entrepreneurs. We've done several successful startups as well as venture, and we like to roll up our sleeves and help companies be successful and not spin their wheels. On a personal note, I've been a private pilot for over 40 years, so aviation is a passion for me, and definitely a technologist and a techie, and happy to be here and look at some of these interesting, innovative companies. Thank you.
Absolutely. Thank you. Sorry about that. Thank you for joining. And without further ado, we are going to begin. And to start off, we have Monarch, and presenting for Monarch, I believe we have Connor, as well as, I'll give you 1 second. Connor.
Hey,
Yeah, how's it going?
good. How are y'all? Thanks for having us.
No complaints. So feel free to share when you're ready.
Oh,
thanks for having us. We've done a couple of these different pitches, so Lots of familiar faces on the screen today. So we appreciate you having us. For those who have seen us, you're going to kind of see an evolution. We started working with the Asher and team not quite a year ago, when we had just come out with our first prototype products. And now we've evolved quite a bit. And it's interesting. I just came back from San Antonio at the AFWorks conference, and people were to ask me what we do here at Monarch. And the simple answer is we solve problems, and we solve the problem behind the problem. In this case, when we first started the company, we looked at what was going on in the industry, and the new armor sets were coming out, thinner, lighter ceramics. It was fantastic, making for better days. Problem was they were doing a fantastic job of stopping the traumatic, lethal event from occurring, but not the actual injury that was occurring behind it. So we started looking at what the industry had, and we realized there were some significant issues going on behind the scenes. So we came up with a product that sits behind the armor to start with, an individual product. And now we've evolved that from an individual product that started with dispersing kinetic energy to a bonded product that actually works in conjunction now with the actual armor itself to allow those armor manufacturers, not just the usual suspects, but the new folks coming on the scene that have really interesting composite materials to allow us to go thinner in preventing the lethality event, but now actually letting us do the hard work on the background, and that's getting that energy out of the way so it doesn't cause and take people out of the fight. All sorts of data behind this. We've written white papers about it because everyone in the industry typically went by NIJ standard, which was all well and good for proving BFD. The BFD we found wasn't the major problem though. It was the energy passing through into the body, which is actually a good thing. And the reason why we're on this today is to talk about how this actually moves into space. So we evolved, this is our third generation product. Our first generation was a standalone pad. Second generation is bonded directly to the new armor substrates. Now we're moving into suits. So the reason the suit was important, and as Martina, thank you for mentioning us, Martina, mentioned as we go into space, what can we do for G-force protection? The battle in space over the next 10 years is going to, and everyone can agree upon this, is going to be very different from what it is here on land. So we built a suit that has the ability to be adaptable into the environment that it's going into. And someone asked me while I was in San Antonio from the Air Force and said, can this help me? How is this helping me? How does this give me a better life? And I said, well, one of the injury profiles that we see of individuals that are coming out in their mid to late 30s are lower back injuries. So if I can help you with not having a lower back injury as you retire from active duty, I think that that's going to be a better day. And oh, by the way, if you are in active duty and you happen to be in harm's way, we can help make that a better day too. So we looked at, some of the injury profiles coming out of the Ukraine, and it was very interesting. A lot of upper thoracic injuries causing, amputations, one arm or both, lots of fragmentation injuries. But we also saw, and you'll see in the diagram here, that the need for spinal support was significant. Moving the weight from a 75-pound ruck pack to parts of your body where you're stronger makes an enormous difference. It actually makes your 75-pound rucksack feel lighter. So we use advanced materials in parts of the suit so that it just becomes your base layer garment. So if you're an astronaut, if you're a special operator, or you're working in maintenance and you're wearing a kit, fantastic. We can help move the weight or move the force to where it makes more sense on your body. So we broke this down into some different pieces using an H harness and a complete lumbar support system. I actually saw in the chat that someone works on different exoskeletal systems. Love to work with you. This is the kind of system that's base layer so that as you build your exoskeleton systems or your exosystems in general, we sit under it. So at some point you're going to have to land, and we want to make sure that landing is as soft and painless as possible. So then we integrate with biometrics and haptics because everyone was telling us in field, we need to understand what's going on with our airmen and our soldiers and our astronauts. We want to keep track of these. Lots of issues with ISR though, right? So we don't want to have sensors out there so that we're lighting up the sky with all sorts of different things. So we had to build this in a way that we keep ISR significantly reduced. So it's in a whole integrated focus. So whether you're an integrated soldier system, you're wearing your MOP suit, you're in the EOD, or you're, an astronaut and you're doing low Earth type of, this is applicable to all cases. So we've been around for a little over, we're going on almost 2 years now. We're in revenue, we're a dual use technology. So if anyone watches football and saw the injury that occurred a couple of weeks ago, that was the original injury profile that we were preventing, and that's called precardial thumb, is when you take a shot directly into your sternum or into your heart, and it causes cardiac arrhythmia, which actually in his case caused an actual cardiac arrest. That's the kind of injury that we want to prevent from, not just on the football field, but obviously in the field of battle that we see as well. And we've done all sorts of third-party testing. One of the things that we didn't do right away is do a lot of BFD testing, because we figured that was kind of fait accompli. Everyone's doing that. And we went back and did it because NIJ said we had to. So we did. And we had an amazing result. We do 31% BFD reduction over existing materials. 31% is a difference in you taking a round to the chest and going home that night. Simple, proven go-to-market strategy. The stuff is all made right here in the US. Veteran-owned small business manufacturer. The people that wear our stuff make our stuff, and that's near and dear to our heart. Lots of partners, lots of major distribution partners. These are sold not only in the US, but in the UK and other parts of the world now, and been vetted out by folks running these in all sorts of different countries at this point.
30-second warning.
Great, thank you. We can obviously our gratuitous slide against all of our competitors, which we obviously win hands down. And we are a dual use technology. This is across the board how we would use this. Obviously, we're going into very large markets. So from an investment perspective, this makes a lot of sense. We're well on our way to our goals in terms of pro forma financials. Our management team, a bunch of old guys, except for Connor, who keeps our average age down. Thank you, Connor. We also have board of advisors that are very experienced with lots of West Point, US Army guys, special operators, and just happen to have a guy that came from running Nike's Innovation Center. So we're doing a Series A fundraise. We just had our first close yesterday. Now we're on our way to doing a final close in the next couple of months. So we're already more than halfway towards our full preferred equity round in this case. So what we're looking for out of this, we're looking for more MOUs and more executive sponsorship of those as we go, with folks working with folks like Martina, who are literally wearing the product. They're going to help us make the product that's ideal for their individual situation. Thank you very much. Thanks, Asher.
Absolutely. Absolutely. And just to give the panelists an idea of how this is going to work, whoever decides to raise their hand first on Zoom virtually, if you put in your picture, I might not be able to see it, but whoever raises their hand can ask the first question and we'll just go chronologically from there. So feel free to all raise them at the same time. Perfect. Rich, you're up.
Thanks, Asher. Monarch, good brief. A couple quick questions and then just a couple notes. Heat dissipation, you guys run into any issues with people overheating with the gear on?
No, so we built this with the some of the first folks we fielded this were in Afghanistan, where it was 130, 140 during the day and down to 40 at night. The base layer suit that we're talking about here today has the ability for thermostasis, which means our goal isn't to keep you warm or cold, it's to keep your body temperature level. And we've come up with a patented fluid, the patent's already been issued, that allows us to do that. So whether you're in Afghanistan or if you're in Alaska, my friends, if there's anyone from Alaska on here who will correct me that minus 40 is a good day there, we also have to cover that as well.
Okay, that sounds good. And then have you guys looked into helmet applications?
Oh my gosh, the multi-million-dollar question. Yes.
Okay.
Lots of different helmet applications. The Army obviously has a lot of different applications going on for it. Helmets are interesting for us in terms of we're working on a helmet liner that allows using our material substrates within the existing shells that are already in existence. So we're not trying to recreate a helmet. We're trying to make the existing helmets actually pass ACH testing.
Yeah, taking baby steps, staying focused on linear impact there, knowing that there's a lot more that goes on,
Yeah.
you know, with the head when it comes to trauma, and, you know, whether it's direct impact or blast.
Yep. Okay. My background's lacrosse. We got that same problem in the lacrosse world. So I'd reach out to the PLL guys, if I were you guys. And then there's some companies making some pretty awesome integrated biometrics for things that go on undergarments. Light Lace is one of them. So I can link you up with those guys if you're interested. That's all I got. Thanks.
Awesome.
Yeah,
Thank
we
you
love
very
that.
much.
Thank you.
Love that.
Perfect. Rudy, you're up.
Hey, I heard the MOU sponsor conversation. So I did mention I'll put more of my information into the chat if you missed it. But in the test place, that's we're pretty much Southern California. It's hot out here. I know you've seen the news. It's been raining lately. But how much testing has been done, or are you looking for more testing to collect more data? I mean, definitely Edwards can definitely partake that and have a couple of our security forces here who do their perimeter checks out and at the gates. And it does get hot here, and it does get real cold out here. Over.
Yeah, we're always looking for additional points to test with, especially as we go into the new suit. We've tested the standalone pad and the bonded product extensively in that environment. Now we're going into the suit to make sure that we can optimize the materials that we're using and the fluid substance that we use. The big thing is, as anyone that's been in the materials business, it's keeping it cool or warm at the moment, but also being able to refresh it, because you're not going to be able to go back to the barracks and, you know, change it out. You have to be able to, so we actually came up with a system to refresh it that you can actually pour water on it. Doesn't have to be bottled water, it can be just regular water, nothing special. We believe very much in blue collar technology. So our technology has to work wherever you are and where you've been deployed.
Copy, thanks. Definitely, I got your information down. I'll reach out and see if we can make a connect to add further testing for your product.
Thank you.
Thank you.
I guess it's my turn, right? Oh, sure.
Yep.
Is it okay? All right.
Yep.
Hey, gentlemen.
John.
Good to see you again. How you doing?
Good to see
Yeah.
you.
I mean, you know, I just for everyone actually, Monarch is the leader of BFD field, and we met him before and through the deep tech space. I mean, deep tech showcase here. But anyway, I was at CES, and actually I mentioned your product to somebody I was discussing, and I thought about you guys, and we probably need to have a chat again. But I know the other gentleman just mentioned about helmet, but I think that's the one area that has a tremendous application for you guys, because that came up during my conversation with somebody. So I'm going to make it short. So we'll probably talk about this offline. Thank you.
Yeah, thank you. Yeah, we totally agree on the helmet side. We're just making sure we go into this in an intelligent fashion, because there's lots of companies that keep promising to do better technology with helmets, regardless of the cost. And because of the sensitivity to it and because of our medical backgrounds, the injury profile that the DoD says is occurring isn't necessarily what's occurring. There's other things going on, and we want to make sure we actually solve the injury problem.
Perfect. Sarah, you're the last question.
Super quick, and maybe I missed this. IP patents around the material. Can you speak to that or repeat from my findings?
Yes, absolutely.
Yeah, so not a chemical patent. It's a layered energy dispersal system, which allows us to integrate different semi-rigid, rigid substrates and the additional layers, adhesives. We basically have come up with a best-in-class use case of a materials package, and have a very tight supply chain around that, but we can easily change things out, right? So this plastic on the front could become carbon fiber. You can unwrap it with the nylon, you can bond it to armor. It's all covered within that patent. We made it fairly broad so that we can, you know, continue to foray into sports and all those things while still being protected by the core IP assets.
And then separate patents around the actual cooling systems.
Yeah.
That are already issued as well.
Okay, perfect. Fantastic. All right. Thank you so much, Connor and Joe. We appreciate it. And yeah,
thanks everybody.
Thanks everybody.
Contact information for the panelists, because it seems like a few people wanted to speak with you. So feel free to reach out to them or leave your contact info. And yeah, thank you again. So next up, we have Summer Robotics, and presenting for Summer Robotics should be Skylar. Skylar, are you here?
Right here.
Perfect. How's it going?
Going well. Thank you, Asher.
Perfect. Feel free to share your screen whenever you're ready.
Okay. Okay. So I'm Skylar Cullen. I'm CEO of Summer Robotics. Summer Robotics has developed a revolutionary perception pipeline grounded in low latency, direct 3D modeling of the world to enable the next generation of machine vision applications in all environments.
Skylar, we don't see your screen yet.
Oh, you don't? Okay,
No,
sorry.
No,
Okay.
no worries.
Yeah, let's see. Okay. Let me. Let's try that again. Okay, do you see it now?
Yes, now we see it. Perfect.
Oh, okay, I'll go to the next slide since I discussed this one. So machine vision technologies are bumping up against bottlenecks in challenging real-world applications. The current vision paradigm using cameras and point clouds results in buffering and transmission overhead and a fuzzy view of objects and their environment. The presence, shape, and behavior of objects is poorly understood and comes highly delayed through a long sensing and processing pipeline. This uncertainty and delay will prevent the deployment of highly valuable services like robotaxis, delivery bots, and many other applications that we've recently been pursuing. So at Summer Robotics, we've re-examined the fundamental assumptions about 3D perception and have developed a new pipeline. Summer Robotics captures surfaces in motion using laser triangulated event tracking. Low power lasers continuously sweep across surfaces and are tracked in 3D by a constellation of event sensors and algorithms. No buffers and always on illumination means that data is turned into object shape, type, and motion information at the rate of the scan. Our whole perceptual pipeline is currently 4 milliseconds long, which is 100 times faster than standard multimodal perception options. So this is our 4th presentation at the Deep Tech Showcase in 6 months. For those of you who have been tracking our progress over that period, we've made substantial technical progress. We've developed 3 new laser reference designs. We've added support for the latest Sony IMX636 event sensors. We've gone from the lab environment to 3 real-world implementation, from a short-range, high-precision handheld scanner to an automotive system, and to a weatherized system mounted on an off-road vehicle. The software pipeline throughput has been increased by 50%. Tracked object bounding boxes have been implemented. Closed-loop scanner control has been implemented. The object classes have been expanded, and along with a whole host of robustness improvements to enable those real-world applications. So since a lot of times I'm told that what I'm saying is a little abstract, what I'd like to do is play a couple of videos showing these real-world deployments and to give you a sense of the data captured by the system and its capabilities. This first demo shows an automotive application of the system highlighting our ability to capture a moving pedestrian in variable lighting conditions. Whoops. Let's see. Does not seem to be wanting to play. Okay, so we'll move on. This is actually a video that's on our website, so I can point people to a link to this video later. So I'll go on to the next demo. Okay, so we've also started a project with another Deep Tech Showcase presenter, Marengo, who are automating a unique single-track off-road vehicle. They need to navigate very challenging terrain in all weather conditions. And so this demonstration shows our system operating in off-road conditions while tracking a person and providing a 3D reconstruction of the terrain in high resolution. Yeah. So what could the Cortex platform do for you? We can help enable autonomy on any vehicle platform by providing low latency, robust geometric perception, which will allow you to navigate any terrain in the air, ground, and underwater. We can help you teleoperate equipment by providing a highly compressed data stream of 3D information intelligently fused with your other sensor data. And in addition, we can implement fixed surveillance systems or close range inspection systems. The company has been earning revenue through sales of software and hardware evaluation kits. We support the latest in industrial event sensors and have developed our own line of laser scanners for use in evaluating our software for indoor and outdoor applications. Our latest hardware and software development kits are available now, and we're working on integrations of our technology with customers in metrology, undersea, off-road, and on-road markets. So we're looking for defense teams that would like to evaluate our technology in deployments in the field, and we're actually actively working on proposals now for doing that. We're applying to multiple government grants and would like to connect with customers who can provide us with letters of support and MOUs. And we'll also be doing a fundraising in the short term. The two co-founders are both technologists with experience as executives in large technology companies in Silicon Valley. And we also have a talented and growing team of engineering experts building the product. And with that, I'd like to thank you for your attention.
And so now, as we said last time, whoever wants to ask the first question, feel free to raise your hand. In the meantime, there was one question in the Q&A. How long have you been training the object detection algorithm, and what kind of data sets, libraries are you using to make it more robust?
So it's a combination of our own data that we've captured in various applications. And also, we've figured out ways to leverage the open source data sets that are based on point clouds. And we essentially turn them into the kind of data set that we use in our underlying system. So we can leverage both existing data sets and fine tune with our own data.
Perfect, thank you. All right, Corey, you're up.
Hey, thanks, Asher. And Skylar, good to see you again on here. I wanted to reiterate, this is a couple of times I've been on the panel and I've seen y'all's technology continue to progress, and appreciate the updates. And just for the audience here and the other panelists, this technology is something that we will be utilizing in an upcoming experimentation activity with the ISR task force. So we will also be putting it on different style robotic vehicles and such with Skylar's team. And we look forward to seeing how that works out. So thank y'all.
Yeah, thank you, Corey.
Perfect. Perfect. We have time for one more question.
I
Actually,
can't
I
figure
do.
out my hand.
I'm sorry.
Sure.
So I was gonna ask how reliant you are on your customized hardware versus putting the software on any of the more traditional off-the-shelf LiDAR sensors.
So there's actually a way for us to leverage LiDAR scanners as the illuminators, but we are reliant on event sensors or SPAD arrays for tracking the data, because those actually provide a very unique capability to observe the signal as it traverses the field of view in microsecond or even nanosecond timescales. That allows us to go frameless. We do have some very interesting integrations with, for example, metrology companies to use standard RGB sensors plus our event sensors plus lasers to do some interesting fusion capabilities, but we do rely on the event sensing like technology for the fundamental data flow.
Perfect. Awesome. All right, that's all the time we have. Thank you so much, Skylar. Feel free to leave your contact information in the chat. I'm sure you know there's a few people who are interested in speaking. So feel free to leave that there. Thank you again for the presentation. Next up, we have Amalgamated Vision. Adam Davis will be presenting.
Thanks, Asher. Can you hear me?
Yep, loud and clear.
Great. And can you see my screen?
Yes, but it's not in presentation mode. It's just
Okay, just about to go there.
Perfect.
And a shout out to Brian. Thank you very much. Okay. Hi, everyone. My name is Adam Davis. I'm the CEO of Amalgamated Vision, and I want to thank you all for being here today. So what we're looking at is state-of-the-art of helmet display for the most expensive and the most advanced aircraft in the world. But in 2017 and 2020 and 2021, 3 near-fatal crashes occurred, and they were attributed in part to helmet display failure. Since 2012, the pilots have reported being unable to understand their surroundings due to disorientation or visual obscuration from the helmet display. On the top image, we see an F-35 helmet with the green light illuminating the pilot's face. And below is a video presented by the US Navy of a pilot attempting to land on an aircraft carrier during low light conditions. In each of these serious incidents, the electro-optics were found to be operating exactly as designed. So the question is, how do we explain this? And I think what we are seeing is the underlying problem of see-through display itself. Anyone familiar with augmented display knows that spatial computing, wearable, portable, digital display that interacts in real time with the surrounding environment is the future of information. But the largest tech companies in the world are failing to deliver successful products for industry, healthcare, consumers, or defense. HMD is bulky, it's uncomfortable, and it's aesthetically unacceptable, and image quality is poor. As a result, a huge industrial and consumer market goes untapped. An army order is lost, a large investment in 5G by the telecommunications companies goes unused. And the reason for this problem is wrong optics. Waveguide or combiner screens that insert data and graphics between the user and the world around them is distracting, and it's confusing, and it's particularly dangerous in high-risk maneuvers in uncontrolled situations. And at Amalgamated Vision, we want to change that. AV is an optical design company creating light engines for the future of head-mounted display. Our tech is not waveguide, it's not combiner, and it is not see-through. Our virtual retinal display is created by an incredibly small and compact optical engine driven by laser light, and it moves through a unique optical design. No other wearable display uses this approach. The images are projected directly into your eye. There is no screen. Our technology completely changes the idea of what head-mounted display should be. Complete environmental and situational awareness, high-resolution, high-quality images, a wide 50-degree diagonal field of view, lightweight and compact for true portability, superior ergonomics, and for consumers, most importantly, aesthetically right. And lastly, extremely bright. You can see it in outdoor sunlight. AV user experience is radically different from all the other VR, AR displays, and we can build 2 form factors. Here we see our binocular form factor. There we go. Here we see our binocular form factor, and it's being used in several different scenarios. It produces a rich 2D or 3D stereoscopic information in a position beneath the user's normal line of sight. The surgeon can clearly see the surgical field and only when needed look down to see the relevant radiographic information. Her view of the patient is not obscured. Our monocular form factor creates a first-of-its-kind user experience. The extremely compact size allows the soldier to wear the device at the inner corner of one eye adjacent to the nose. One eye sees the display, the other does not. His brain fuses the input from the 2 eyes, so the information is overlaid in his normal visual field, but the environment is not obstructed. Depending upon where he looks or directs his attention, the display will be completely inconspicuous or plainly visible. Our intellectual property is protected by 4 US patents, and in 2020, Amalgamated won the NASA iTech Innovation Competition. Augmented reality user needs can be classified along 2 axes: by their degree of data complexity and by the user's need to be present in their environment. Today's leading HMD products typically only serve 1 class of user cases, depending upon what the manufacturer intends to do with it or the limitations of the optics inside. The AV optical engine is an enabling core technology. It can power any of these experiences, and it excels at the most difficult data-intensive tasks while still ensuring a non-obstructed view of the world. Our technology has wide commercial applications. The potential market for industrial and consumer products alone is estimated to be $20 billion by 2026. Our preferred business model, AV Inside. We intend to license our technology to strategic partners in the consumer electronics, telecommunications, healthcare, and defense industries to place their applications inside their specific application eyewear. AV has raised $1.4 million to date, including income from a customer who paid us to complete the design for our optical engine. We're ready to build the prototype now, and you can be ready in 7 months. We are asking for $1.9 million to complete the build out and obtain relationships with strategic partners. The AV team is our greatest asset. Our engineers are among the best in the world at optomechanical design for head-mounted display. Our business, legal, and administrative team is highly experienced. In conclusion, AV is ready to change the landscape of head-mounted display, and we're actively seeking partners, and we really hope that you are interested and that you guys will join us. Thanks very much. Happy to answer any questions you may have.
Perfect. Awesome. Thank you so much, Adam. All right, without further ado, Corey, go right ahead.
Thanks. Great briefing. I do have a couple of questions over with regards to the certification processes for this, since it would be in the aviation community a pilotage and navigation source of information. How are you going about dealing with, one, the FDA for clearances associated with shooting light into your eyeball, and then two, like DO 178 Charlie for software safety for pilotage of aircraft for airworthiness release? Over.
Okay, so laser light power is always a concern, like any light source. If not used correctly, it can be damaging to the eye. But the interesting thing about our optics is that they would normally not be used for an LED or micro LED display because they're relatively inefficient. We use a pancake lens and there's a lot of light loss. But for us, using laser light, that's an advantage because we are actively trying to remove 95% of our light. Our current module is designed to be 3,000 nits, and that makes it a class 1 laser, utilized in all situations without any restrictions. So when we apply for regulatory clearance, we will be applying as class 1 laser light, class 1 laser product.
I'm going to jump. Thank you so much. Quick question for you. For the 1.9 million you're seeking to raise, help me understand what other resources or hurdles exist for you to complete development of your product and get to a production ready product this year.
If you cut us a check today, we would have a working prototype in 7 months. We've already finished the detailed design phase. We currently have no regulatory or legal restrictions or any kind of encumberment to moving directly into building the prototype.
And do you have customers lined up that would be ready to prototype that capability this year when that's available?
Yes, actually, there are companies in the telecommunications, in the electronics business, in the defense industry, who we have spoken to have told us that they are waiting to see our proof of concept. They are very interested in an extremely small, portable, lightweight optical engine for head-mounted display.
Okay, thank you.
Awesome, awesome. Next up, we have Martina.
That was a great presentation. I really enjoyed it. I'm interested, how many changes did your patent went through? You said 4. Did you have any functional working prototypes that you changed over time, or was it just a conceptual thing?
It was conceptual all the way through. Our patents are for 2 things. It's interesting. Optical design, of course, but also form factor. We patented the idea of taking a laser MEMS, which is a well-established technology, passing it through optics with a diffuser to increase the exit pupil so that there's a wide sweet spot for the eye to see, and keeping that within 16 millimeters of the eye. That ultra near position, that form factor, is part of our patent claims that were granted.
Thank you, Adam.
Yeah, I can't figure out how to raise my hand in this thing, so I'm just gonna jump in.
Shout it out.
Yeah. So in terms of your go-to-market, how are you thinking about the defense side? Just as like a comment, like, you know, on its face, I'm not sure I'd go after like the pilot, you know, opportunity right off the bat. Right? There's probably easy, like lower hanging, less challenging use cases to start with. Yeah.
Absolutely. I mean, the military is demanding, of course. There are tremendous opportunities in the military. The best example is that the IBIS, the augmented display for soldiers, that which was being supplied by Microsoft, the HoloLens system, that's, you know, that has been faltering, and that is in jeopardy. So you know, the opportunity within the military is wide open. But as you said, that's a tough nut to crack right out. You know, it's funny that the largest applications for this, the really deep pocket, is industry, and they're going to probably be the first adopters of this. Warehouse workers, they need hands-free, wearable, portable display so that they can move things from shelves. And efficiency of warehouse workers is essential for, you know, large distribution companies, for Amazon and FedEx, UPS, and, you know, all of those companies. So, you know, as a go-to market commercial, you know, those lower demand applications would probably be almost easier than moving into the military. But remember, this is a new emerging technology, so very often it's the military that kind of supports that kind of novel technology. And within the military, it doesn't even need to be a warfighter. That's what comes to people's minds. But for mechanics and engineers, when they're fixing things and they need those schematics and they need to use both hands, that's a great application.
So I'd recommend like reaching out to Natick Soldier Center, right? Like they're probably the part of the Army lab system that'd be particularly interested, and then there are going to be elements of SOCOM that are going to be particularly interested, right? Like SOFWERX might be an easy point of entry to just like start having conversations and start kind of get oriented on those end users' needs. Yeah, neat stuff.
Thank you.
Han, you have the last question, all right?
Sure. Thank you. I'll make it quick. Thank you. Hey, Adam, good presentation, good technology. Actually, I love it. I know you mentioned that your customer pay for R&D or development. Are you in any kind of restriction with ITAR field? Like if are you at liberty to say, let's say you actually develop a product and sell the license to a foreign entity friendly to USA, of course, but.
No, we have no restriction. And the interesting thing is our customer, of course, they want our technology, but they also recognized that there was no market leader in the field and that this field was having failure to launch. So they put no restrictions on us and encouraged us to sell to as many people as possible in order to try to stimulate the head-mounted display field. Our customer is a data analytics company. And what they do is they take disparate types of data and bring it together into one visual experience. And they realized that they didn't quite have the display system that they needed. So they're actively trying to encourage the data display. So no, we have no restriction for any customer in any vertical.
Thank you.
Thank you.
Awesome. Thank you so much, Adam. Be sure to leave your contact information in the chat. That was fantastic. So next up, we have Tip and Q.
Hello, everybody. Can you see my screen?
We can see it. It's not in presenter mode yet. Oh, there it goes.
Should be about now with the lag. Pleasure to connect with all of you. I'm happy also to close this session. My name is Avner Bentheim. I'm a co-founder and CEO of Tip and Q. Background also a reconnaissance pilot. Different roles in the Israeli Air Force, head of the Signal Intelligence Department, Corporate Innovation Department, and Space Program Office. Tip and Q is a multinational company founded in the US and in Israel. So we're at Tip and Q, looking to be the signal source of truth. Founded 4 months ago, hit the ground running already with some compelling tech and a working proof of concept, working with some design partners. I'll present in a minute. Our vision is to keep every moving system 100% always connected. We believe that the way to do this is by providing a scalable layer of spectrum visibility. And once we know where these connectivity icebergs are, whether connectivity gaps or active interferences, we can then ensure seamless wireless connectivity. We see radio frequency interferences as the modern day icebergs. Mobility system across all domains, air, ground, sea and space all depend on wireless connectivity to safely navigate and communicate. And we're creating the world's most accurate source of wireless connectivity intelligence. A little bit about the problem, divided into two. First, people think that the wireless spectrum is somewhat static. The truth is exactly the opposite. Extremely variable and dynamic, affected by variables such as weather, co-channel interference, congestion on certain system, and frequency, as well as active jammers, both military jammers and commercial, affecting all the above domains. The second part of the problem is that we've got accustomed to working blind in the spectrum, coming as a acute pain from the military world. As systems become more interconnected and autonomous, we can't afford to work in the blind anymore, losing equipment and even affecting the loss of lives. And this is the same for the commercial market as we move more towards autonomous systems, UAV, connected mobility. We have to know where we're moving in the spectrum, where we're to expect connectivity gaps, and how we could adjust our operations accordingly. The solutions out there today are hardly inadequate to what the industry needs. On the top left, you have these high level coverage maps, which aren't granular enough and don't give the user what they need into where to expect connectivity gaps. Then you have these spectrum analyzers trying to look for needles in the haystack, giving you a really localized situational awareness and not the situational awareness you need, scalable across vast areas. Military sensors, which are highly limited and where you could place them, both ground sensors and aerial sensors, and really focus on geolocating the source of interference and don't always give you the situational awareness needed. And at the end, what the industry needs are accurate maps that are scalable and also online, and they can see what's changing in real time and how to adjust your operations. Our solution allows any user to choose an area of interest or a route of interest, whether it's in the air or the ground, the frequency of interest, focusing in the beginning on cellular and GNSS, and afterwards also working towards KU, KA, and Wi-Fi. And then every user gets a granular map of where they can expect connectivity on top of the active interferences caused by jams, network outages, and so on. And the highest level is the ability to also forecast connectivity based on past events using AI, and also recent events. You're able to know, on Tuesday afternoon, there's certain jams going on in that area, and then you could expect to use a different frequency and adjust your operations. The way we do this is 100% software, so no hardware installation. First, we have our proprietary coverage maps for the different frequency bands, understanding where the satellites are, where the base stations are, and giving this very detailed coverage map, any point, any altitude and place in the world. And then on top of that, aggregating data from multiple domains and sensors, such as aircraft ADS-B data, AIS, cellular data, and other sources. Most of this is acquired, but we're also able to integrate data through MOUs for defense partners. So we also give the outside world data, as well as creating situational awareness through their own sensors in a classified environment. We see this opportunity as a horizontal software as a service for multiple domains. As a commercial domains, we're hitting aviation and ground mobility first, together with UAVs. And as a defense and government market, the different regulators, defense application, both air applications and space domain awareness, as well as law enforcement. A little on the tip of the iceberg, the aviation use case, where we have a working proof of concept here, where we could allow any regulator, airport or airline to be able to forecast GNSS interferences, also differentiate between spoofs and jams, and then really see what's going on across different times. It could be a week back, a month back, seeing the different trends, when they can operate in which areas to expect interferences, and also create this real-time map, allowing to adjust operations. This is for commercial aviation, for defense, It's not only knowing where you could fly, it's also the ability to then go to green zones. You kind of reamp your ability to work in the GNSS contested environment, and you can know where to go to renew your system, reset, and then go back and work in a GNSS interfered environment.
30-second warning.
Okay, great. I'm ending here. Traction with a few design partners, both in aviation, geospatial intelligence companies, as well as UAVs. I'm biased, but we have a great team with over 70 years of experience combined in geospatial intelligence, signal intelligence, and aerospace. We're looking to connect different partners in the DoD for grants and mainly just to solve your problems. And we're in the process of due diligence for a pre-seed round. So connect to any interested investors, both for pre-seed and seed. Thank you so much.
To raise your hands. We'll get to the questions in the order of the hands raised. So go right ahead.
All right, I still don't have a hand raise button, so again, I'm going to jump in. Hey, so are you considering establishing some kind of like U.S. entity?
Yeah, so we have a U.S. entity, and that will be the mother company, and as well as an Israeli entity. But yeah, so we could fully apply for SBIRs, grants, and mainly U.S. based.
Thank you. Hey, I don't want to repeat the same thing here to everybody here, but could you tell me just a little bit about how you work in the RTOS space again with the technology? I really think that your technology actually has a very great value to the market, actually. So
how we're working in what space?
Oh, ITAR, your technology with US and allies. Okay.
Yeah.
Are you at liberty to share? That's one thing.
Sure. So in our initial frequency bands and solution, we won't be ITAR limited, giving both cellular and GNSS. That's mainly commercial scalable technologies, kind of like spectrum weather. You can see it as weather just for the spectrum. Of course, providing solutions for KA, KU, and different military sensors. This will create a separate entity and be limited most probably by ITAR.
Okay. All right. Thank you.
Right ahead.
Thanks. Avner, good brief. There's one question in the chat. I'm also kind of curious. They said, how do you pull data from 5G sensors? Cellular nodes typically don't expose their RF data to third parties.
So the data that we get from a third-party cellular data is RSSI data. From satellites, you get accuracy, location, and cellular data is signal strength and upload and download speed. And this is data that you could acquire, and it's also compliant with GDPR and not giving away any personal information. Same kind of information that you could buy through car connectivity as well as retail. But we just started doing something we find far more compelling with it.
Gotcha. And then the software solution you guys are using, is that looking also at possible terrain masking from interference when it's building out the mapping?
Okay, great question. Yeah, so our first layer aggregates both, APIs from the satellite location and base station, correlating that with topography and 3D buildings. So we create really this heat map. Sometimes you're operating a drone in an area from the get-go, you only have 3 satellites and you're ready now in a good situation to start flying. So that's the base layer that's crucial for us, because then after that, cross-correlating that with the real-time sensors, you're able to know, okay, you're in an area where you're supposed to have good connectivity, but now there's some kind of interference going on. So that's a crucial aspect, and that's part of our forecasting models.
Got it. Yeah, that's awesome. I see a lot of application for potential small UAS, how you get them in and get them out of different areas. So good work.
Thank you.
and then it went back down.
I had the same question around data verification and pulling this off without deploying any of your own hardware or sensors. I think he answered it.
Okay, perfect. Perfect. Thank you so much, Avner. And feel free, again, I'm sounding like a broken record, but leave your contact information in the chat, and hopefully people will reach out and, sometime to speak further and further understand. Perfect.
Well,
all right.
thank
you so much. And with that, we conclude part 1. We are now on to part 2. I'm quickly going to just read off the panelists because we are running slightly behind on schedule. Continuing to join us from the USACO group, we have Han Ko. Joseph Blehut is also continuing with us from the U.S. Air Force. Steve Elefant is going to be continuing as well from Soaring Ventures. From Stellar Ventures, Noah is going to be on the call. Noah Feingold is going to be on the call as well. Corey Anderson is also continuing. From the DIU, Sarah Pearson is continuing with us, as well as Andrew Boudet from Air Force Futures. From AppWorks, we're going to have Bennett Stewart. And from the U.S. Air Force, we have Rich Kelso. From Invest Puerto Rico, we have Peter Ruiz. From the U.S. Air Force, we also have Rudy Besa. From the Federal Development Agency of Ontario, we have Craig McClellan. From the U.S. Air Force, we have Higley. And from Lockheed Martin Ventures, we are going to have John Richmond. Hey, welcome, John. And last but not least, Martina Demosca is going to be continuing with us as well. So thank you for all the panelists who are now joining. Without further ado, I am pleased to give the floor over to Gregory Davis with Aviation, who's going to give us some interesting insight into electric aviation.
Thank you very much. Let me just get this presentation here. I'm going to start with a short video, which will take a little bit of time, but let's hope this works this time around. Can you see my presentation? All right, good. On September 27th of last year, Aviation flew the world's first all-electric commuter aircraft, the Aviation Alice. And the reason why it matters is because that flight wasn't just about putting electric motors and a battery on a plane and flying it. It's a custom-designed aircraft built around the electrical propulsion technology. And that aircraft had all of the technology that you need in order to commercialize the electric plane. We're in a situation right now where aviation currently accounts for 3% of all CO2 emissions globally, but by 2050, we're going to be accounting for 25 to 50% of all global CO2. The aircraft that we have right now, they generate noise restrictions around the existing airport infrastructure. Aviation fuel is expensive and continues to increase in price, and we haven't seen any new technology really come on board to actually, shall we say, create a game changer in the aircraft industry. Really, since we went from the Super Constellation to the 707, or the piston engine to the jet engine, and that's exactly what we're here to do. So we're creating a 9-passenger commuter aircraft. It's electric, so it literally produces no emissions while it's flying. The motors are virtually silent when the aircraft is at idle, and we're designing the aircraft to be very quiet. And electricity derived from the grid is anywhere between 1/3 and 1/10 the cost of aviation fuel. And we're the first to take on this challenge. So this is going to change the way that the industry works. The way it works is we've actually found what we call is the sweet spot for electric aircraft technology. Half of all of the flights in the world are less than 500 nautical miles. And moreover, a full 20 to 30% of flights are 250 nautical miles or less. And when you look at again, the sweet spot for the electric plane, what we found is that the commuter category, so Part 23 or commuter category certification, is the clearest path of certification for an electric aircraft. The aircraft that fly in that segment, there's about 50,000 GA aircraft, general aviation aircraft in the world right now, 35,000 in operation, and about 4,000 aircraft that are operating on those routes that are 250 nautical miles or less, which is the direct entry market for Alice. But our approach is to build a conventional takeoff and landing aircraft that operates from existing airports using existing airspace with the same certification standards of any other airplane. And that's how we're going to get the aircraft to market. It's going to be a game changer. So we talk about it in terms of the 3 C's: carbon, cost, and convenience. So carbon, as I said, 0 emissions. Cost, there's only one moving part in the electric motors. The maintenance cost of the aircraft are going to be substantially lower than a conventional turbine aircraft. But convenience is why this works, again, with that sweet spot. In the United States today, looking just at the US, there are 5,000 airports. Only 500 of those are what we call fully serviced, and another 1,500 or about 2,000 airports are actually designated as underutilized by the FAA. And so what that means to us is that 95% of the population of the United States lives within 25 miles of an airport, an existing serviceable airport, but we actually drive on average more than an hour to catch a flight somewhere. And so what we want to do, what we are doing with our aircraft here is we're actually providing the vessel to facilitate the reintroduction of regional air mobility, connecting communities point to point. That's our sweet spot. So we're looking at 9 passengers. Going back to the second C of cost, 9 passengers is on purpose. In the United States and Europe, or North America and Europe for that matter, 9 is the limit that you can fly with a single pilot. So you can have 1 pilot and 9 paying passengers. And that's important right now, especially because we're actually operating with a global pilot shortage. And of course, pilots add cost to the aircraft operation. So we know where we are in the marketplace. And I can say very confidently that we are ahead. We know we are ahead of the competition, 1, because we've actually flown our aircraft, 2, because our customers are telling us, and 3, because our supply chain is telling us. So we're the first mover in this space. And again, going to the cost here, projecting out our maintenance cost of the aircraft, it's what we call a fly-by-wire aircraft, or the controls of the plane are computerized and it's still controlled by a pilot, but it means there are, again, fewer moving parts, less serviceability issues. The control surfaces are self-calibrating. Again, the electric motors, reduction in fuel system components. There's actually a lot that stacks up to make the aircraft much cheaper to operate than the conventional aircraft we're used to today.
30-second warning.
Perfect timing. So we're the first to market. We're the leaders in battery technology. Nobody else has we have the advantage in terms of getting a certifiable aircraft battery into play. We've purposely designed our aircraft to be beautiful. We're working with the best suppliers in the industry to make sure that we focus on what we're good at and we get them to focus on what they're good at. And we've been in with the FAA for several years now, and we know that we're ahead. So this is Alice. We're in the middle of a Series B raise, and I'd be very happy to answer any questions.
All righty.
Everybody.
Yeah.
Thank
you.
I
Hey.
don't have a hand button
actually,
either, but had a question.
Actually, can you? I'm sorry. Dan, could you hold on 1 second? I had a hand up a while ago, so I'm sorry about that. But I'll go first.
Okay, you'll go next.
Yeah, you can go next. Thanks. Hey, sorry about that. But anyway, I mean, I actually great to see you again here. I know about a year ago. I mean, by far, I know indeed you're the leader in eVTOL field, right? Because I think about a year ago that you had a first flight, correct? Because I remember, yeah, seeing that that in the on the media that then I ran to you actually. But anyway, I was actually following up about your company a little bit since then. I just got two questions here. First of all, I know your flight range is about 500 miles, unless I'm mistaken, correct?
We're going to enter into service with a 250 nautical mile day VFR range.
Right. Okay, I got it. And so how much cost? I mean, number one, so how long is the battery lifetime on that? And also, what's the cost of entire, you know, in other words, your pricing scheme, if you sell the plane industry right now, in the market right now, then how much cost?
Okay, so the battery is being designed to have a 3,000 cycle life, which equates to about 3,000 flight hours. And we don't release the pricing of our aircraft, but I can tell you that you know, we have over $3 billion in sales, and you know, we've placed several hundred aircraft. Yeah.
Oh, you already have a $3 billion sales.
We have $3 billion on our order book. Yeah.
Gotcha. Okay, thank you.
Yeah.
Thanks. Greg, quick question for you. Look by the schematic there, the batteries in the back of the plane. Question regarding the turn time availability to move 9 passenger. I think it's a great idea, but obviously time on the ground is going to be a factor if you want to turn that jet. Is that battery line replaceable, or what's the time to charge on it?
Yeah, so the batteries weigh about 8,000 pounds, and so making them line replaceable would require a lot of specialty equipment. But no, it's a design consideration. So same as the life cycle the operating life cycle for the battery, we're designing it for 2C, or 1 hour of flying time can be charged in 30 minutes. So it's the same as a typical turn for a conventional aircraft. Yeah.
Perfect. John, you're up.
All right, that's pretty awesome. I have a lot of questions for you, but decided to pick one. Let me go with, so what parts of your technology are designed and built in-house, and what do you outsource? And how did you arrive at that decision?
Yeah, so the first off, we own and will own and hold the type certificate for the aircraft. So just from the overall control of the platform, that's going to be Aviation. In terms of the technology that's going into it, so we're leaders in terms of the battery system integration. So consider this, that an electric airplane, the battery, of course, is your fuel source for your motors, or your call them engines, but they're really motors. It's also the power source for your flight control system. And so it integrates into all aspects of the aircraft's operation, and we're by far leaders in terms of the aircraft systems integration and oriented around battery technology. And then, I mean, that's really key. It sort of sounds obvious when I say it, but you know, electric airplane, our strength, of course, is the electric technology.
Yeah, that makes sense. I'll do one more quick one and let the next folks jump on. So $3 billion in sales, is that bookings, or is that revenue? And what do you think you'll do in revenue?
It's under LOIs with varying degrees of commitment. Okay, so we're very clear. If you look at all of our press releases, we're very open about what we're doing. But you know, it's real customers. So Cape Air has ordered 75 aircraft. They're looking at converting their entire fleet out east to electric. DHL has been very public about their order of aircraft. It's what we call a starter order for 12 planes. Global Crossing, which is an established airline out of Miami, and then just recently Air New Zealand, so a tier 1 flag carrier, selected us as part of their group, their initiative. I mean, New Zealand's a thought leader in terms of sustainability as well. And then there's some interesting new airlines that have actually started. These are people experienced with air operator certificates, but they're starting new businesses based around the sustainable technology.
Very cool. Congratulations.
Thank you.
Perfect. Thank you. Peter, you're up. And last question.
Well, awesome. Well, I just wanted to clarify the ownership of the company. I know it started as an Israeli company in the US, and then I think it got some investment through Singapore, somewhere in Asia. But is it a US company, or is it owned by a foreign entity? Or I just wanted to kind of clarify some of that.
Yeah, that's right. So our majority shareholder is the Claremont Group out of Singapore. The company was founded in Israel in 2015. We're here as an American entity. I'm in Arlington, Washington, just north of Seattle right now. So yeah, that helps. That's the answer. Yep.
Perfect. Thank you.
Perfect. Thank you so much, Greg. Feel free to leave, whatever information you want to have people reach out. That was a fantastic presentation. Next up, we have Accrete presenting, and feel free to start sharing your screen when you're ready.
Hey, terrific. Thanks, everybody. I'm Jason Kirby. I'm the COO at Accrete. We're an artificial intelligence company. We were founded back in 2017. We're based primarily out of Lower Manhattan. We're about 2 blocks away from Wall Street. We also have offices located in Boston and in Alexandria, Virginia. So the company is working across 5 verticals currently. So started out in finance, e-commerce, insurance, media, entertainment, and then defense as well. And we started out with a financial platform looking for alpha within the markets. And we've also transitioned towards a few different variants of social media exploitation as well. The first one was for one of the top 3 record labels in the world. And that was to identify up and coming music artists based upon social media narratives. So that product successfully converted into licensing. And has, over the course of the last several years, been renewed. So we then transitioned into defense use cases in 2019 through the Defense Innovation Unit. We successfully completed a prototype for a supply chain risk management platform that was focused upon our adversaries. And then that also transitioned into a multi-year production OT license as of last year. And you can find more information about that in the DIU annual reports for both 2021 and 2022. We're a DoD prime defense contractor with that contract, and our focus is on dual use technologies. So not principally focused on defense, but on any commercialization opportunity as well. And that's what we use as a core component of our strategy. Okay, for the next slide. Our 4 principal product offerings are listed here. And so I'll start with the upper left-hand corner with Argus for supply chain influence. There was a recent article in the Washington Post highlighting a couple of US-based companies, and I'll drop the link into the chat, that had inadvertently sold their technology for hypersonics through a number of intermediaries, and that was subsequently sold directly to the Chinese Institute for Aerospace Technology, where they interviewed the scientists and they came back and said we wouldn't have a hypersonics program without the technology that we had acquired from the US. We were able to identify those companies that were listed within that article and identify the chain of custody with the platform. And that's one of the principal uses for that platform that we've been able to license to the DoD. On the upper right, we have a logistics resilience platform that we're in development with now. That also was selected and is an open and active contract through the Defense Innovation Unit as well to identify down to the component level potential logistics impacts to individual components within items that the government would be purchasing. In the lower left-hand corner, I talked about the social media intelligence platform that we licensed to the record label. That's now in conversion for defense use cases. So targeting networks, identifying information operations and opportunities. And our key focus area there is on analytics. So making predictions about the likely effect that we can have with a social media campaign, or that our adversaries can, or tracing back misinformation. And then lastly, in the bottom right-hand corner, a reverse engineering platform for simulating foreign microprocessors in a simulated environment where the functionality of the microprocessor can be explored and identified. We've been doing that with the Air Force. Next slide. Okay, in terms of the key asks that we have and how you could access the capabilities that we developed. Like I mentioned, we do have an open and active contract with the DIU. We are looking for a government sponsor, and that is for that logistics and supply chain resilience capability. With AFWorks, we also have an open and active contract for that social media exploitation platform when we recently were selected in the last tranche of phase 2 SBIRs back in that were submitted in November. And then in about a month's time, we're going to be listed on GSA, and the platform, which we call Argus, for supply chain influence, will be available to government purchasers. Next slide. We're also looking for letters of support for upcoming SBIRs, as you see here. For each of these, they're really across the 4 principal platforms that the company offers currently. And then lastly, in terms of our strategy going forward, as a prime contractor, we're in active discussions with FSIs for looking for partnerships, as well as developing our cadre of resellers. And then, of course, we're also looking for capital partners as we're between a Series A, which was completed, and transitioning to an institutional raise coming up over the course of this year. And I'll stop there and take any questions that you may have.
All right, Jason, this sounds like it could be a great solution for some of the problems that we've got in the fighter enterprise. If anybody's been a part of fighter aviation, we run out of parts all the time for no reason, because we can't keep tabs on our supply chain and what still is standing and what's not. Have you guys talked to the fighter program office at all?
No, we haven't as of yet. My background was in Air Force Special Operations. I was a pilot there. So I'm definitely aware of supply chain issues with C-130 parts and the CV-22 especially. But I absolutely appreciate an introduction.
Okay, I'll see what I can do there. And then TRL wise on the different products, are these all baked, ready to go? This is something that can be applied, assuming you get a license?
Yeah, for the Argus for supply chain intelligence, that is a TRL 9. The social media platform, we expect it'll achieve TRL 7, and that will be in the April timeframe. The reverse engineering platform is currently a successful prototype. We've not converted it to a product as of yet, as we're still in dialogue with the Air Force customer. And then for the logistics component, that I would say that is coming up on a TRL 6, but it's not quite there yet, Rich.
Okay, got it. Thank you.
You bet.
All right, thank you, Jason. A good presentation, and you have something really good going there. Appreciate it. Just a couple of quick questions here. First of all, I must say that I really like the example you came up with, how your product and services can help for the mistakes that somebody made accidentally leaking our technology to our adversaries, right? And the question that I have is that you're looking for capital as well, or seeking capital partners, and if so, how much you're looking for, and can you share what's for?
Yeah, we are looking for capital partners, absolutely. And I'd love to have a follow-on conversation with yourself, as well as bring on my CFO directly. That raise, I would expect we're going to be looking between 50 and 75 million for that next tranche of funding, and be happy to discuss that with you further.
Okay, sure. Let's get connected later. Thank you.
You bet.
Perfect. We have time for one more question.
I have a question. I don't have the hand either.
I don't know why that's happening. I'm sorry about that.
No worries. So for I guess the Argos platform, is there currently like a program office that is housing that, or is this kind of more of a license, and then a few agencies have requested the licensor?
So it is currently licensed to an intelligence agency within DoD that was the original sponsor of that prototype development through the DIU. Now, in terms of that platform and making it available through licensing to other customers within government or in the commercial space as well, because we're seeing a lot of interest of late in supply chain assurance on the commercial side as well. Like I mentioned, it'll be available for licensing through the GSA, and we could also do direct contract as well. Does that answer your question?
It does. Thank you.
Okay.
Oh, you almost answered mine there in the last one, but I was curious what revenue models you're exploring with your DoD and government customers? So SaaS, but are there others?
Yeah, in terms of the revenue model, let me see if I'm answering your question accurately. We base it upon data. So we welcome as many users once we've entered a licensing agreement that want to use the platform. The more, the better, of course. But it's based upon ingestion of data. So we've seen the system ingest as many as 125,000 documents per day. We have a data model that is built around that. So as additional data is ingested based on the customer's needs in consultation with them, that's the licensing model that we've used successfully with DoD.
Okay. Yeah, I guess I should have been a little more direct. Are there opportunities for long-term contracts that you're exploring, or is it recurring SaaS?
Yeah, that's a multi-year contract as it is. Yeah.
Thanks.
Perfect. Perfect. Thank you so much, Jason, and the Accrete team. Fantastic presentation. Next up, we have Exelarium, and presenting will be Rahil and Nasser.
Hi, everybody. So let me share my screen. And we can get started. Okay. All right, so I'm going to be introducing Exelarium. We are a company started in 2020 by an experienced team from Qualcomm, Intel, and Broadcom background, and we are developing technologies that enable the convergence of sense and communication. So as commercial applications move from mid-band to high-band frequencies, there is both an opportunity and a confluence of different types of capabilities like RF sensing and wireless communication in the millimeter wave band. This is brought on by also AI algorithms that are being applied here. So what we see as a result is the need for processing wideband signals, so gigahertz to going on to several 4, 5, 10 gigahertz and more as we move from 5G to 6G, but also a complex mix of workloads that is a mix of traditional signal processing, high performance computing, and AI machine learning techniques now applied right next to the sensor or the antenna. This has to be done with extremely low processing latency. And however, all of this must still be done with low SWaP-C because die size, area, and power constraints still apply to devices at the very edge. So if we look at conventional architectures and opportunities, traditionally these high band applications are addressed with ASICs. They are limited in flexibility, very difficult, costly to develop, take 3+ years to develop and $50+ million. Or the alternative are traditional programmable solutions like FPGAs and GPUs that are simply too expensive and too power hungry. We believe that a new type of a programmable architecture is needed for this application. And that's what our Hydra, our dynamically reconfigurable edge processor architecture accomplishes. So we offer C programmability with ASIC SWaP-C. So the cost and power profile of hardwired solutions with the flexibility of C programming. So we're significantly lower in power consumption compared to traditional programmable architectures and offer reconfigurability 1,000,000 times faster than FPGAs. This platform has been optimized for the convergence of RF sensing, communication, and inline AI machine learning. The first embodiment of our platform, the XLR1000 cognitive RF processor, is a device that's capable of processing signals all the way from L-band to X band, K band, and W band, and everything in between, from 10, really focusing on the millimeter wave spectrum at 10 gigahertz to and above, but also applicable for wideband signal processing in the traditional mid band and low band frequencies. This is built around our proprietary reconfigurable compute technology, which offers C programmability with a much faster reconfiguration time and lower C swap than traditional FPGAs and GPUs. We see that there are many use cases and applicability in the USG applications. We are a commercially focused company, with focus on automotive and enterprise applications. But for defense, we have seen an increasingly large number of use cases, from miniaturized cognitive radios. These are battery-backed, personnel-worn, multi-standard, multi-band, radio devices that could benefit from this technology. Fully adaptive radars, wideband RF spectrum sensing, again, requires very much the same attributes. There has recently been a lot of activity with LEO satellite networks, non-terrestrial networks coming up both in commercial and defense applications, and we're certainly applicable there. And of course, within the larger enterprise and industrial applications, the ability to use millimeter wave spectrum and terahertz bands for precise 3D positioning and tracking is one killer application that is bound to change the way logistics are done. Occupancy monitoring requires, again, similar capabilities, low latency, high bandwidth compute coupled with AI and machine learning at the device edge. So we see a number of end applications that benefit with low power, field upgradable communication, RF sense, and edge AI capabilities within a small form factor. Yeah, so we have a tape out. We do have a virtual platform now. We expect the first tape out in 2023. So in terms of overall where we're at is that we are looking for seeking investment partners and as well as end users within the US government. We do have an MOU already for with an Air Force research lab, or we're looking for additional letters of support and MOUs for applications of our technology, and as well as corporate partnerships for developing production silicon and as well as software partners as well. We do finally have a licensing a core available for licensing, and we do have an initial licensing customer with a $3+ million revenue in the pipeline today. It's an experienced team, as I mentioned, with Qualcomm and Intel background, and we are based in Orange County, California, and that's all from us, and we'd be happy to take your questions.
Corey, go right ahead.
All right, thanks for a great brief. This is exactly the type of stuff I'm looking for. So you hit the nail on the head with the RF sensing spectrum component of this, but I do have questions. You said you can use C or C++ as your language, but what ISA is this? Is it a RISC-based computer or CISC-based computer? How are we?
Yes.
Is that ISA available for people to work?
It is. So we are fully compliant with RISC-V ISA and RISC-V vector. However, we have proprietary extensions that enable us to handle with hardware scheduling layers the dynamic reconfigurability that's under the hood. But we're RISC-V compatible, and that opens up huge compatibility on software and tool chain and so on.
Excellent. And then the last question is, obviously you're working on the chipsets, not necessarily the hardened form factor. Is that a true statement?
And so no, we are taping out our chip. We will be selling chiplets, and also package chips, if that's your question. But we also do selectively license our technology in applications that require, integration at an SoC level. We believe for US government applications, mostly the chiplet ecosystem is the way to go. I don't know if I answered the question you raised though.
Yeah, you did. I was just trying to ask, you're not building a hardware around your chips today to put it on a board and then put it into a hardened solution. You're just focused on the chip architecture, correct?
That's correct. We're focused on the chip, but not the board and the enclosures. Yes.
Excellent. Thank you, sir.
Thank you.
Perfect. We have time for one more question. Go ahead, Kelso.
I'll do it. I'll ask another one. Raheel, who are you guys talking to in the Department of Defense, if anybody?
We're Air Force Research Lab. We've been working with them for some time, based out of Dayton, Ohio. So we're working with those folks, and we are new to the U.S. government's ecosystem. So we certainly appreciate any introductions, and feel free to reach out to us if you want to talk or make introductions.
Yeah, this is it's so foundational tech-wise that I would be pointing you to other people that would use the chip for things that I don't understand. But AFRL is definitely a good start. DARPA is another one I would point you to, and then. Where are you guys envisioning producing chips?
Right. So our first chips are being developed in TSMC technology. However, we also have had discussions with Intel for their 16 nanometer fab, but we expect TSMC to be the commercial tip outs.
Gotcha. Thank you.
Thank you.
Anyone else who'd like to speak, feel free to leave your contact information in the chat. I'm sure there should be some really good follow-up conversations. All right.
Thank you.
Perfect. Next up, and the last for this session, we have Alpine Technologies.
All right, let me get my screen shared here. Sorry, it's not giving me the right window. There we go. All right, can we see the presentation now?
Yes, but it's not on presenter mode yet.
There you are.
Yep, you're good.
All right, cool. Well, thank you all for having us here today. My name is Jeremy Smith. I'm with business development at Alpine Advanced Materials. We are an advanced materials company, so it's right in the name. What is an advanced materials pursuit? From the market's perspective, especially in the aerospace and defense world, there's a challenge to reduce weight with composites, but typically with composites, you see an issue with either scaling for production, cost competitiveness, or both combined. What we do is try to tackle those challenges in our own little way with a number of high performance materials. But what we have that is a novel material, it's a multi-scale reinforced polymer called HX5. It was developed by Lockheed Martin Skunk Works for the F-35 program, specifically to replace 6000 series aluminum. And if you look over on the right-hand side of the screen, you see at the top bullet point is 93% the strength at 50% the weight of 6000 series aluminum. So its specific strength compared to that 6000 is about 80% higher than its competitor. So we do a lot of metallic to non-metallic conversions with this material, but we also will do origin part design. And as I said, we work in a number of different materials. This is just the material that's the most novel and a new technology that we were able to bring to the market. It's incredibly environmentally resistant. Caustic chemicals, it stands up to tough radiation. We've tested against 5 million radiation or 5 million gamma radiation rads with no degradation. So it's excellent in a space environment. It's got a great temperature profile. It's a very durable, highly engineered thermoplastic material that we do injection mold. And when we're considering metallic to non-metallic conversions, that's where the injection molding really can give you a cost competitive nature and a scalable solution. So having a material that can perform metallic strength requirements, but at the same time be scalable and cost competitive is unique. What we do with the process is, one, we really take a part that was designed to be machined aluminum or machined stainless in some cases if it's an environmental, not necessarily a strength challenge. But we will do some optimization to make that moldable, which is the first part of our process, but that's just one part in our process. From there, we move through to do like a mold flow analysis so we can understand the carbon fiber alignment. This is a fiber filled material. That's what that multi-scale reinforcement really means, is it's got multiple levels and sizes of reinforcement inside it, all the way from carbon fiber filled down to nanoscale reinforcements. So we can characterize that fiber alignment doing mold flow analysis, and from that run a high confidence anisotropic finite element analysis to deem if the part will meet given requirements for the application. And then from there, we'll either iterate to optimize the design or move to manufacturing. We will do the tool design for you, but something we've been able to capture in the recent months is shooting the HX5 material into existing tools that might have been built for peak 30 or other just general high temperature thermoplastics that are carbon filled. Because the HX5 material has a better viscosity than those materials, we've been able to go into those existing tools and either just decrease the mold pressures to be able to shoot on a smaller machine or with less energy input by up to 50%, or we can go through and decrease the runner system of the process to reduce the waste by up to 60%. So that's less wasted material with the same tool design and gets a better part output than a comparable material. And when you're considering injection molding, there are challenges when it comes to the prototyping avenue. Something we've developed is a process we call rapid prototype molding, RPM, tried to give it a little speedy nickname there. But essentially, we are 3D printing a single-use mold. We will print the mold, inject into it, and then dissolve that out, giving you an injection molded part within days. With a significantly lower investment that then you can go and test. It would have better mechanical properties than additive prototyping, and allows you to test, iterate, and move on with your design without building a dedicated tool to it until the point you're ready to move to that scalable production, which is where we'll design the full production level tool. So that's a bit about what we've done with the material. Where we're using it right now, you see the cross section of the markets that we're currently serving. A lot of our business is in aerospace and defense. Obviously, lightweighting goes a long way to flying further, flying faster, flying a heavier payload. UAVs is also a big market that we've been servicing for those same value add propositions. But at scale, it's not really limited to things that need to be lighter weight. It is a environmentally agnostic material. It's great with hybrid solutions, so we're able to combine it with aluminum through an overmolding process. We also bond well with other carbon fiber reinforced polymers to give it a unique, we can use the best properties of both those materials and a happy marriage of dissimilar materials. On our product development roadmap, I just mentioned some of the things we're developing with hybrid solutions using dissimilar materials to come up with a whole higher level assembly, essentially. We're working on developing a unidirectional tape to apply this in non-injection molded scenarios. We're also working on a 7000 series aluminum competitor, trying to get a similar resin system that has a higher, basically tensile and flexural strength than what the HX5 does.
30-second warning.
Thank you, perfect timing. And the opportunities we're looking for here, we are pursuing a couple SIVers, and we'd like to continue that effort. We have open doors for potentially joint developments with it pertaining to our product development roadmap or specific product applications. And we see a number of avenues within the aerospace and defense world, mostly secondary structures, but anything that could be a machined aluminum component is a candidate for conversion to a thermoplastic like HX5. So that's it, and I'll open it to questions.
Dan.
Excellent, thank you. Great briefing. I'm very much interested in learning more about this. One of the questions that I have obviously is the thermal characteristics of it compared to aluminum. Aluminum can, bleed heat pretty quickly. How does this compare in that thermal properties?
Yeah, so this is a thermoplastic, so it has similar thermal conductivity to aluminums, which when you're trying to dissipate heat is a challenge. That said, we can, with the hybrid solutions of overmolding, we've had experience overmolding cold plates into our material. So that would be an aluminum plate that does transverse the heat. We can also do, we're pursuing essentially 2D conductive coatings. This material accepts coatings extremely well compared to other semicrystalline thermoplastics. So what it can do is essentially dissipate heat in a 2D manner if there's an escape path. So long answer to say that there are several ways to achieve that, but the material itself is not a great thermal conductor.
Got it. And obviously not an electrical conductor either, right?
It is a very low-level semiconductor, and I can give you all the data that details that. And we can do a coating that either enhances or decreases the surface resistivity because we can do a number of different functional coatings with the material.
Excellent, thank you. I'll be reaching out.
Thank you.
Perfect, Dan, you're up, and then Andrew.
Hey, Jeremy, great brief. That's awesome technology. I was wondering if you could talk briefly some of the rough tech specifics regarding the rigidity relative to the size, strengths versus that product versus metal, and also some of the fatigue details if you've gotten into those.
Sorry, what was the last that you said, the T details?
Sorry, the fatigue.
Fatigue, gotcha. Yeah, so we have characterized the fatigue profile and it shows excellent, both creep and fatigue profiles are excellent, all things that I can share with you pretty easily. But then when it comes to, I guess, the rigidity over the size of a part, that's part of our design process is tailoring that fiber alignment to give you that rigidity. The part can be, really any size and geometry, and we're able to go in and tailor that fiber alignment to meet the load requirements of the part. But suffice to say, it's I may be biased here, but holding the part in hand can be pretty impressive. We just got in hand essentially a 32-inch disc that is light as a feather, but as strong as an aluminum would be. So in form factor size, we're limited to the size of injection molding machines, but we've gotten to pretty large parts with significant rigidity, all the way down to very simple brackets that maintain essentially the look and feel of an aluminum component without the weight.
That's great. Thank you.
Perfect. Andrew, you're up.
Great stuff. I had a question with respect to, I guess, the modularity and the portability of the technology. And then that might, I guess, if you're a little bit restricted to the injection molding process, that might answer it a little bit. But I guess, are you guys looking at potentially 3D printing as a method with this product, like filament or deposition with a powder?
Yeah, so we have done filament printing with it. It is a challenge because the material, like thermoplastics, is a brittle material, and to produce a filament, you would need about 100-foot bend radius. So it's not necessarily practical. It is possible. What we've done from the 3D printing avenue is a dedicated machine was built for materials like this, and essentially it melts the material at the nozzle and then lays down layers. But through that process, you don't get fiber alignment across layers. So at 45-degree or 90-degree against the fiber alignment layers, you're leaning to the strength of the resin system, which, most of the strength from this is going to come from the fiber alignment of the part. When it comes to SLS printing, we had a trial years and years ago that essentially, I believe the powder couldn't bond to the catalyst agent. Not to say it's not possible, but that was an avenue that we didn't pursue very far. We actually went towards that RPM process because we saw the value in that as a rapid prototype avenue. And we also have other avenues of prototyping that we're pursuing as well.
Perfect.
Awesome. Yeah, there might be an application that I have contact with an engineering depot maintenance team. They kind of are in that modularity portability form factor, but I'm sure they would definitely be willing to kind of have something like this within their toolkit. So I'll definitely be reaching out after the showcase event.
Absolutely. Thank you for the question and the connection as well.
Perfect. Perfect. Thank you so much, Jeremy. All right. And that concludes session 2. And now we are on to session 3. And I'm going to quickly read off the panelists who are continuing. It's mostly continuing. So from Stellar Ventures, we have Noah Feingold. From Architect, we have Corey Anderson. From the Defense Innovation Unit, Sarah Pearson is going to continue with us. From the Air Force Futures, Andrew Boudet. From AFWorks, we have Bennett Stewart. From Invest Puerto Rico, we have Peter Ruiz. From Meta, we have Sofia Moshasha. From the U.S. Air Force, we have Rudy Besa. From the Federal Development Agency of Ontario, we have Craig McClelland. From the U.S. Air Force, we have Dan Hingley. From the DIU, we also have Ryan Weed. From Oikoi Network, we have Owen Mayer. From Capital Innovators, we'll have Frank Hopper. And from Lockheed Martin Ventures, we'll have John Richmond. And last but not least, we'll have from NASA, Martina Dimosca. Thank you for all the panelists who are staying on and all of the ones who are joining for this session. Without further ado, in terms of companies, I'll just quickly give you guys a sneak peek. We're going to start off with Rocket Star, followed by Serenius, followed by Intrepid, followed by Kelvin, and finishing off with Edgy Bees. So Rocket Star, if you're ready, feel free to start sharing your screen. You're up.
Copy that.
Perfect.
Okay, just have to get to the presentation part of it.
Sure.
I always forget where that button is.
There's a few of them.
Yeah.
That's the confusing part.
Here we go. Okay. Yeah, I'm not staying up to with the updates. Hi, everyone. My name is Chris Craddock. I'm the CEO of Rocket Star. I'm going to just go over briefly today a little bit about what we do to two of the major tall tentpoles, the Aerospace and in-space propulsion. So currently, you're dealing with 2-stage at best, 3-stage to 5-stage launch vehicles. Why that's bad, in our opinion, is over complexity and high cost. You throw away a lot of this stuff. It's difficult to put it back together. It's time consuming, and usually you don't get the desired orbit or the desired inclination that you're looking for. You have to just go along with the bus. What we're looking to do, what we're working on, is actually achieving a true single stage to orbit, fully reusable launch vehicle that can give aircraft-like access to space. How we do that is through an updated Aerospace. And our idea is not to just have it so that it's going at the same cadence it is now, but we want it to have eventually hundreds of thousands of launches on a daily basis all across the world, much like we have with aircraft. And this is exactly what we're powering. Right now we're doing traditional looking rockets, but eventually we're going to get into the space plane side of it, where we launch like a rocket. We come down on pretty much every FAA compliant long runway airport, so that we can pull it into a hangar, do a couple of checkouts, refuel, refit, get it back out on the pad. Why is that possible? What is the difference? So just to go over quickly, bell nozzles are what's on everything right now. They're bounded on all sides, so the exhaust, when it comes out, it doesn't change. But of course, when air pressure changes as you fly upwards, that changes, but it doesn't create a one-to-one profile. It's one of the reasons why they have to ditch and have to use a much larger skirt when they get higher up into space and to higher altitudes. Aerospikes are the reverse. They're bound on one side and they're open to the air on the other, so that as the pressure changes and the exhaust plume changes, it changes along with it. So it gives a theoretical maximum of a one-to-one capability with thrust. How we differ versus the past, some great inventions happened in the past through Aerojet Rocketdyne and other companies. Chiefly, it's because of 3D printing. As you can see, we have 3D printed, and that particular picture, it's a titanium, I believe, 60, and that came
from concept to in our hands, we had a prototype that was ready to be fired in 13 days. So thermal capabilities, 3D printing capabilities, commercial off the shelf has gotten a lot better. A lot of our technology is also advanced along with it. We're trying to get to a point where it's complete reliability, better power at the pad. Most bell nozzles are optimized for that 14 to 20 kilometer range. They're not optimized for off the pad. So when you need all that lift to get off the pad, it's not there. With the Aerospike, we can get up to 20% more lift. Right now, we're at about 11 to 18%. So further deadlier on both the aircraft, manned or unmanned. We've got a lot of traction on the government side. We have what do we have with NASA? We have so many different documents with NASA, it's hard to keep up. A lot of different research possibilities with them. Working currently with AFRL Agile Battle Lab on some interesting applications, as well as in-space propulsion with SSC and AFRL. The commercial side has not been a light interest either, although they are taking definitely a forward-looking approach. Space flight, especially now since it's had problems with SpaceX, they're very, very keen to get on our launch manifest as we develop. And to that point, we just recently had a demo launch September of last year that we got her on the pad, we got her packed with Tricep's help, we got her pressurized, but there was a fire and we've since scrubbed that mission and now going to be doing the next one in May. So we should be mission capable from an orbital perspective, either late this year or early 24. At the end of the day, with full reusability, it becomes very cheap, very capable, very quickly. Most of these other companies, they're still on the build and dispose model. Firefly, give an example, great company, great team, but they're going to be building 200 building 200 flight vehicles a year and doing 200 launches. So build 200, get rid of 200. Totally, they have some of reusability of the first stage. We can do 1,000 launches a year off of 40 flight vehicles. So once we're mission capable, we fully expect to just blow this out of the water. But time will tell. It's obviously a very large market. These numbers are actually a little bit light because they don't include the mega constellations. We're currently servicing and in contract with a few companies to do their initial constellations as well as initial small sat launches. But we fully expect to service the second generation, so the replacement satellites as constellations get more mature. Oh, when you get to orbit, it's completely inefficient to then use a chemical rocket, no matter how efficient it was on the planet in space. But the problem in space is it has thrust capability of most thrusters, Hall effect thrusters, electric propulsion methods of a potted plant. We aim to change that by adding fusion to the exhaust gases of water-based and other type thrusters.
3-second warning.
Good. I'm coming up on the end anyway. We have an existing contract with SSC to develop a in-space thruster on the tune of a half a Newton to a full Newton capability. We've since had some interesting developments that show our 160 millinewton thruster was able to double its capability just with a little bit of boron in the exit gases. Just an overview of some of the key personnel. Myself, I've been doing business on Wall Street and other companies for the last 15 years. I have my degree in physics. Jack Fox is our Chief Operating Officer. He's been a shuttle hugger and managing the shuttle since '81. Co-founded SwampWorks at Kennedy. Brad Berkson is our government liaison. At one point managed $2 trillion for the government doing procurement for pretty much every level of the DoD. And he was the guy checking out the technology before it was implemented into the military. We're currently in the middle of our Series A round. While we're happy to have new conversations with new partners or new technology transfers, the main thrust right now is raising capital. So more than happy to have discussions in that area. And I'll conclude it right there and just open it up to questions.
Thanks. Great presentation, a lot of questions. Single staged orbit, obviously a big challenge from a technical perspective. I think most people would say that you need to double the ISP of current kind of bipropellant propulsion systems to make it work. And then X-33 tried the Aerospike back in the 90s. What technologies are you using to differentiate yourself from those? Because what I can tell from this presentation is that the Aerospike gives you a 5% advantage or so in ISP. So, and then one thing, this is a follow-up question. What are the typical mass fractions and overall vehicle size in terms of kilograms that you expect to achieve?
So we're gonna adopt a crawl, walk, run sort of perspective. The current flight vehicle that we're testing and fully expect to go into production will only lift about 150 kilograms to start at maximum. And it may be essentially a cheat SSTO, where we're getting very close to orbit or doing a very low Earth orbit and barely doing a lap, but then pushing out an ESPA ring that will then insert the payloads into the final orbit. We fully understand how difficult this is and how many people have tried it before. And we have some special sauce that we feel can get over said humps. But you know, it's a big chunk to kind of eat through and get through, and it will either be the ugliest two-stage launch vehicle out there, or we'll actually have something that'll work. So, but for the success of vehicles, we're already planning on doing upwards of between 500 to 200 kilos to, I don't think it's going to get much farther than 500 kilometers up initially. But again, that it's going to come down to, are we just doing a one and done SSTO, or are we going to do some sort of combination where we have like a Sherpa vehicle that then pushes out and then we capture it back and bring it back down? Very similar to the way that Rocket Lab is now talking about their Neutron vehicle.
So for the 500 kilos to 1,000 kilo to Earth, low Earth orbit, are we talking like a 10,000 kilogram wet mass, or 1,000,000 kilograms, or what's the size of the vehicle?
I don't see that getting over 25,000 kilograms wet mass. But you know, we're early on. We could turn a corner and find something and decide to go bigger or smaller, some combination.
Great, thanks.
Perfect. Peter, last question. You're muted.
Sorry, the question was answered, so I'll let it to someone else.
Okay.
No worries. We have time for one more question. All right. It looks like there might be one in the Q&A. Let me just check. Okay. Since current windows for space flights are limited, how do you plan to mitigate those atmospheric challenges to expand the amount of flights?
Yeah, so we've been investigating a lot of different pads. Right now, we're doing a lot of experimentation in Mojave, but obviously that's ceiling limited. One such area that's shown a lot of promise, and we fully expect to be out with them in the testing this year, is the Spaceport Company, where they're planning on doing barge-assisted launches out in the middle of the ocean. It's an area that we played with ourselves a few years ago, which we didn't have the capability at the time. And we're very happy to support a company that's doing that, specifically because how difficult it is to get in line at a pad, as we found out with Kennedy. It's a very busy launch area. And that can be said pretty much about every pad that's out there in America right now. So getting access to launch pad capability out in the ocean, whether it be in the Gulf, out in the Atlantic, or what have you, I think will ultimately open up a much bigger window for not just us, but a lot of different companies.
Are you only vertical launches, or can you do horizontal?
We're in talks to do horizontal as well, but that's a different project that may just only be an up and down sort of delivery mechanism.
Okay, perfect. Thank you so much, Chris. Feel free to leave your contact info. All right, Tom George is up with Serenius app.
Thank you, Asher. Let me just share my screen and let me know if you can see it.
Can't see it yet. Now it's.
How about now?
I see
Okay,
it.
good. So when you say go, I'll go.
Go.
All right. So hello, everyone. I'd like to thank the organizers and the attendees of the Deep Tech Showcase. It's been a long session, and I'll try to keep this short. And I'd like to thank the organizers for kindly inviting me to present the case for my company, Serenius. Space has long been the domain of national governments, but recently, as you have seen from all the presentations before me, it's become an exciting new frontier for commercial exploitation through the availability of cheaper and more capable satellites and launch vehicles. Serenius considers satellite Earth observation as impacting daily decision-making in multiple global verticals. And therefore, we are aimed at creating entirely new global data and information markets through the acquisition, high-performance edge processing, and rapid delivery of daily actionable information derived from satellite Earth observation. And here, H-cubed stands for high spatial, temporal, and spectral resolution imagery. Although global Earth observation impacts multiple business verticals, our initial beachhead markets focus on agriculture and defense. In agriculture, early warning is key. We derive the most value by telling farmers what they cannot see with their own eyes. Daily data-driven predictive agriculture has been called the fourth revolution in agriculture, and Serenius aims to make it a reality. For DoD ISR applications, Serenius H-cube solution saves lives, equipment, and costs while minimizing misidentified events or false positives and missed events or false negatives. In the 6 years of our existence, we have achieved significant traction in gaining both commercial and government revenue. Among the DoD applications, Serenius, in collaboration with the Aerospace Corporation, acquired and analyzed airborne hyperspectral visible near-infrared and long-wave infrared imagery in the Colorado Rockies for the Air Force's Weather LIS, or Land Information Systems Model application. Shown here is the daytime hyperspectral LWIR image acquired of the Ridgway Reservoir. Among DoD applications, Serenius deep learning algorithms operating on a high-performance edge computer detected both sub-pixel airplanes as well as this single flying airplane shown here within a 65 megapixel Worldview 3 multispectral image in under 45 seconds. Serenius successfully demonstrated its high-performance edge computing solution on board the D-Orbit Ion spacecraft released from a Falcon 9 in 2021. And on the right, we see the detection of a plane taking off from Hong Kong Airport. One key H-cubed application that we are currently developing for the Air Force is the rapid generation of 3D digital twins for mission training and mission rehearsal applications. And here we are collaborating with Presages and L3 Harris corporations. Given our contract revenue funded approach, we have kept our internal team small while leveraging a very large ecosystem of small and large companies and premier government organizations and laboratories. Our near-term goal is to raise $1.8 million to be matched 1-to-1 by the Air Force's TAC-5 program, for which Serenius is eligible by virtue of winning several SBIR Phase 2 awards. With that, I'd like to thank you once again for your time and attention, and I'm ready to take any questions.
Perfect. Thank you, Tom.
You're welcome.
Sorry, guys, I can't find my hand raise button. Is it okay if I ask a couple?
Yeah, go for it. Go, Corey, and then Martina is right after you. Because I think you started
Awesome.
before she raised her hand.
Thank you. The question I'm having is your business specifically, are you building the sensors or are you building the high-powered compute that rides on these spacecraft with the sensors built by someone else, or what is it specifically your company is building? Over.
Oh, good. That's a great question. And it's kind of a two-part answer. So what we have focused right now is the most critical aspect, which is the current paradigm for in-space data is to downlink all of the raw data down to the ground. And this is particularly true for NASA satellites, where all the L0 data, as they call it, which is the raw data acquired by the sensors, is downlinked down to the ground. So we want to flip that paradigm around because satellite Earth observation data is currently not business relevant for most government satellites. There are commercial satellites that are trying to reduce the time to delivery. But even then, having high performance edge computing on board the satellite can reduce the latency significantly if it can provide actionable information, as I said, with low false positives and false negatives. So we focused on that as the immediate aspect. And now what happens for the H-Cube solution is that the information that you can provide your customers, the actionable information, is only as good as the data that you acquire. And so currently there is no one acquiring hyperspectral data with high spatial resolution on a daily basis anywhere on the globe. So ultimately the plan would be, in case other companies haven't come up with it yet, is to build a constellation of hyperspectral satellites with high spatial resolution that covers about 400 bands, all the way from the visible to the long wave infrared, and be able to do the AI/ML or the deep learning on board the satellite in order to provide actionable information for multiple business verticals. I hope that answers your question.
Sort of, yes. So are you working on the algorithmic functions associated with the imaging, or are you building the processors? I guess.
Right. Good. Sorry. Go ahead. I'm sorry to interrupt.
No. I'm just trying to figure out what material solution are you actually developing with your company? Is it the processor itself? Is it the algorithmic functions that are riding on the processors? What is that material that you're delivering?
Got it. So it is the ultimate sale will be of information, but what we are internally developing are the algorithms that ride on a high performance edge computer. So we have tried out a bunch of different edge computing solutions, and it's a down selected one which actually flew, as I mentioned, on the D-Orbit Ion spacecraft and demonstrated that we could do process worldview 3 imagery, for instance, in 45 seconds. So when it comes to the processing chain, if you're familiar with NASA's terminology, they have L0, L1, L2, L3, and L4, L4 being the actionable end. But then in between, you have a lot of interim steps where you have to correct for atmospheric absorption, lens corrections, etc., orthorectification to make it geospatially relevant and so on. So those processes right now are being conducted terrestrially. So we want to move all that up on board the spacecraft so that the delivery will be of actionable information, which can accommodate the current low bandwidth that we have. I mean, communication bandwidth is a huge limitation when it comes to how much data you acquire and how much you can downlink down to the ground, especially for L0. So we want to take away that limitation by doing L0 to L4 on board the satellite.
Okay, great. Thank you. Software. Appreciate it very much.
Oh, you're welcome.
Martina, and then Reg, hopefully we'll get to all of them. We don't have too much time, so let's try to make it.
Hi, Tom. Thank you for the lovely presentation. I saw some NASA partnerships since I am on that side of the spectrum. Can you please tell me what were your biggest projects and what was the outcome?
So with NASA, I have not, other than the, we got an award from the INVEST program for building the first ever hyperspectral thermal imaging satellite. It's called HI-T. It was a partnership between my company, JPL. I'm originally from JPL, and the University of Hawaii. So it was to demonstrate hyperspectral thermal imaging analysis with a little bit of onboard processing, not the full chain.
Thank you so much.
You're welcome.
Perfect, Reg, right ahead. If you still have a question.
Sure, I'll reach out to Dr. Tom directly. Thanks.
Okay, not a problem. All right, thank you so much, Tom. Feel free. I left your contact info, but if you want to leave it again, no one's going to complain.
Thank you, Asher. Thanks a lot.
Next
Thanks
up,
for the opportunity.
Absolutely. Next up, we have Intrepid. And feel free to start sharing, Maren, whenever you're ready.
All right, we're getting our presentation up. Okay.
Okay.
This one?
We see the wrong screen, so you should switch it.
Switch it?
Yeah,
Switch
with
out.
the presenter, like in the in the display settings. You can yeah, you can swap. Yeah.
Display settings.
No, no, no.
Gotcha.
Yeah.
I gotcha. How's that?
No, so go up to display settings on the current screen. You see there's a little tab. Oh, okay. So if you go into the presentation mode, there's a little tab called display settings that you can swap the screens.
Okay. Sorry, we had to swap out computers.
No worries, it's all good.
I'm not seeing that. I'm hitting display settings. Sorry, I'm hitting display settings, but I don't see it.
No, so it's in presenter. So try start presenting again.
That one.
Gotcha.
Yeah.
And then stay on that screen, and then there's another tab called display settings on the top. On the top. Yeah, you have to go up.
Oh,
Yeah. And then there's an option to swap.
You see?
Right here. This guy.
Ah, there we go. Fine.
Okay, here we
There you go.
There we
Okay.
go. Sorry.
All right, time starting now.
Yeah, exactly.
Okay. All right, thanks for your patience, guys. So we are Maren Muxlow and Chris Tanner of Intrepid Automation. We are a San Diego-based company. We are right down the street from the Miramar Air Station. So you might hear some of the planes flying overhead, and we build solutions for 3D print technology for use in investment casting. We provide an entire solution: 3D print hardware, software, materials, automation, and quality control. So the primary applications of our technology is basically anything that's an end-use metal part. So as you can see from the slide, it's something like a jet engine turbine, a blisk, a boat propeller. 90% of metal things use a casting process to come to life. So just a little bit of background on investment casting for those of you guys that are not too familiar with it. It's basically this process right here. And kind of the interesting thing about our technology as it relates to investment casting and why it might be relevant to some of you is that because it's such an old process, it keeps existing regulatory requirements in place. And lots of legacy parts are required to use investment casting as a manufacturing process. So anything that uses a single crystal alloy, anything that uses a super alloy, it gives you access to thousands of alloys versus dozens, which a nascent technology like metal printing wouldn't be able to have access to a lot of those materials. So there are some issues with it though, however. So for large volume production, it's slow, expensive. A lot of the really innovative designs that are coming out in astronautics and aeronautics, it's difficult to do it with wax. Those are tooled. So with our process, you can get to the same end use metal thing in days versus like sometimes actually years. Our technology solves for all of the challenges on the prior slide. So this slide is basically about the advantages of digital casting, which is a 3D printed pattern versus a wax pattern. So not only is it faster, significantly faster, it's more accurate, it's less expensive, it allows those complex geometries, it keeps existing regulatory requirements in place. It's great for legacy parts, for something that's like an older part, you can scan it, 3D print the pattern, and then cast it with access to a foundry. The patterns are more robust. So this is actually like one of the patterns, right? Like you can pick it up, you can touch it, it won't mess up the surface finish if you touch it with your fingers. You can ship it around, send it in boxes for people to look at, presents significant advantages, especially when iterating new technologies. Our technology, compared to other players in the field of 3D printed casting patterns, this graph was presented at the Investment Casting Institute International Conference by Tom Mueller, who's a really notable researcher in that field. Our process is significantly faster, it's more accurate, and it's less expensive. So this is how we did it. We're vertically integrated, so we make our own resins. They're optimized for our systems, and we built everything with automation in mind from the very beginning, which is a differentiator to our competitors. These are two of our hardware solutions that are presently making patterns for customers. So the one on the left is the fully automated system. It has a smaller print bed, so it's like about this size. It's good for like brackets, like small cast parts, like little things, right? The large format system is you can see the sizes on there, but this is like a real application for it, like a customer application, a wheel for a car. It gives you kind of a good sense of the scope. So we have a robust IP portfolio, several patents, also international. One of the things that is kind of bears mentioning with this slide is we are ITAR registered. Our ISO is in progress. All of our patents are around the idea of automation regarding this process, building something out this way. We also have proprietary materials and a lot of different materials kind of in the pipeline at various technological readiness levels, some of which are actually pretty high, though this presentation focuses on the casting itself. So though we're a small company and a fairly new one, we've been able to scale up pretty quickly by leveraging industry relationships and partnerships. So we have a $1 billion contract manufacturer is already fabricating our systems, and that's not on site, it's off site. We have a drop ship model for our materials where it can be scaled up very quickly. And that's allowed us to secure agreements with tier 1 customers in automotive, energy, private aerospace, machinery. We have strategic agreements in place for multiple hardware deployments this year. So industry validation, just the logos show some of the conferences that we've been invited to present at this upcoming year. I really like this slide. We had a camp at our lab called Girl Meets Additive Manufacturing, where we taught a bunch of high school girls how to do some CAD design and then printed some parts for them. It was on the news here in San Diego. It was pretty cool. Our team is a deep technology team. Some of the pictures were pretty funny, so I just kind of took them off. But among our team, we have chemists, engineers of every discipline. Collectively, our founding team has over 300 patents. Among our board members, investors, and advisors, we have the CEO of a very large contract manufacturing company, former chief executives from leading 3D print companies, Stratasys being one of them. Dr. Paul Jacobs, he literally wrote the book about 3D printing, and Tom Mueller, noted veteran research and advisor and well-respected member of 3D print community as it relates to casting itself. So our ask today is to engage on projects or initiatives related to both large format and high volume pattern production, this casting application that we've talked about, supply chain optimization, legacy parts in particular. I think I was kind of worried about going over time, but I don't think we did. This is just a summary slide. If anybody wants a copy of the presentation, it's just kind of a summation. And that's us. Thanks so much, you guys.
All right, Corey, quick draw. You're up.
Thank you. Thank you. Yeah. The question I have is are your printers basically still compatible with traditional languages for the 3D CAD model moving into your system, or is that a proprietary activity?
Oh no, we're very agnostic. We can pretty much do anything, but no, we're yeah, STL, the traditional, not a problem. Yeah, but we didn't touch on it much, but that's another part of our innovation is how we get the digital flow in. All our systems are on the cloud or off the cloud if it's an ITAR or that type of deployment. But we often write custom APIs and things like that to ingest digital information. So the first image that Maren showed, the system on the left, it's literally a digital flow in, fully cured form part out. All automated, all the slicing's automated and all that as well. So it takes a lot of the humans out of the equation and on multiple levels.
Excellent, thank you.
Perfect, Sarah.
Thank you. So awesome presentation. Can you shed a little more light on what you're doing in the defense space today? And if that's through primes or direct with, yeah, government or not?
Right now, all we're doing in the defense space is a couple of different SBIR proposals that are in process right now. So not really, the answer is not much right now. We're looking to get into it.
Yeah, we're producing. So the large format part, that the other printer you saw was actually commissioned by a private aerospace company for producing aerospace parts. And we typically on a weekly basis are printing you know, tens or dozens of parts in there for aerospace. So, you know.
Okay. Second quick question while I'm off mute. In terms of fundraising, can you share a little bit on what that journey has looked like and where you're at now?
Yeah, so we're actually in the middle of a funding round right now. I think total, I think we're at about 8 million to date over the past, like since founding. So we're presently in that process.
And what will that money help you do? Where will
a few different things. Firstly, we have a few different applications that will be a better on-ramp for these large format. It's like a large piece of capital equipment, right? It's like a $2 million purchase, which of course people are a little bit like, that's a big thing, right? So we have kind of pipelined a better way to on-ramp that where customers will feel more comfortable making that purchase, ways to investigate how to make the purchase easier for customers.
Okay, thank you.
Perfect. Kelso, you're the last question.
All right, I'll make it quick. How are you guys so much faster than other people in this space?
Oh, so that's a great question. That one, and it took Tom a while. We've had a long relationship with Tom in investment in casting in general. That was the first resin we developed at Intrepid a few years ago, and because he was really, I think, kind of nervous of showing it because it was so different. But typical SLA type printers are laser based. And our system is actually DLP. So there's actually 6 in this system. We call it Valkyrie, based after the early 70s aircraft that had the six largest jet engines at the time. One of my favorite planes. And we have 6 of the largest 4K projectors on top. So we have patented a way to automatically calibrate those projectors so they act as one. And I think we're the first ones to ever do it. And obviously, we like I said, we have a patent on that. So literally, the projector, one goes out, we can swap another one in. There's no physical manipulation of the projectors themselves. It's all done digitally with a sensor array we have under it. So it's all automated. And yeah, it's pretty neat. It's pretty neat to watch that image just go layer by layer. And that's really the difference. That's why you saw the cubic centimeter, because it's that whole volume at once versus a single laser trace.
Yeah, that's awesome. And then just to clarify, you guys basically do the resin cast. Once that's done, if we went into product actually made, we would send it somewhere to get the actual basically steel forged or whatever.
We have several partners all over. We do a lot of aerospace, medical, dental, automotive. We kind of cover the whole gambit. So,
Got it. Thanks, guys.
yeah.
Perfect. Thank you, Intrepid. Feel free to leave contact information in the chat.
Will do. Thank you.
Great presentation. All right, next up we have Kelvin. Presenting for Kelvin is Chad. Chad, are you with us?
I am here. Yes, sir. How are you doing?
Doing well, doing well. Good to see you.
Good to see you. Let's see. All right, everybody should be seeing my screen now. Thank you, everyone, for giving me 5 minutes of your life today. Happy to chat with you about Kelvin. My name is Chad Stewart. I'm the VP of Sales here, and we are a collaborative control software company. And you're scratching your head, exactly what does that mean? A little bit about us. We basically, our mission is to deliver autonomous operations. What is that? We're taking a collaborative approach where we're really looking to implement what we call co-pilots in order to make quicker and faster action that delivers impact. We do this through multivariate optimization. So while we do things around increasing productivity, profitability, and yield, we also want to achieve other goals, and may it be sustainability or other things that are important to you. So ultimately, our mission is to combine artificial intelligence that can augment the humans, and so that the humans can make better, faster, quicker decisions. Kelvin's been around for about 10 years. We have 100 employees. We're across 5 different companies. Cut our teeth in the energy sector. We're currently looking at mining, and we're looking at food and bev, and have a host of different companies interested in pulling us into new sections. This conversation is really around how this tech is transferable to you and your use cases and your pain points. We really want to combine this AI to solve real world problems. And like I mentioned, we can go after things like mechanical failures or efficiencies, or even your carbon impact. The results are staggering. Right now, we have customers that have use cases that have 74% reduction in methane while increasing the production by 20%. We've been able to increase the $100 million in production while decreasing 40% in energy usage. One of the latest ones is the reduction in methane emissions in Australia with a customer, where we were able to mitigate the emissions there by implementing a simple routine that mimics humans. So what matters to you most? At the end of the day, you want to make more, you want to break less, and you need to save as much time as possible. All of these things have knock-on effects to increasing your profitability, reducing your carbon impacts, so on and so forth. Additional problem that we have run into so much is we just don't have enough engineers in the world. We're solving that time equation by building these applications that augment the existing humans so that we can move the bodies around where it makes sense. One customer we have is 700 engineers short right now. We're able to build specific co-pilots to them to be able to move those engineers into more reasonable positions. How do we solve it? This is going to be a really daunting question for lots of folks whenever you start to talk about that digital journey. But it really starts with one engineer, with one process, with one problem. Often that problem is still existing on some antiquated tech like a spreadsheet. We can take those low-hanging things and take those and automate the manual tasks. Out of that, we've built 2 products. Kelvin Maps is really around finding your problems. You can collaborate in real time across your systems. This system is underpinned by a failure mode database that was built over the course of 25 years in reliability. So it is built on 35 atomic table components that can tell you the failure modes. We've layered AI on top of that, which can go in and tell you faster, sooner, and quicker what those failure modes are looking like and what the problem is, so that you can begin to build co-pilots to fix your issues. Many co-pilots that we've built are basically a manifestation of your best engineer. What did Joe do yesterday that was just better than the rest of the team? And how can we make that copy of that person and standardize and or scale that person across different business units? My use case is Halliburton. We have done this. We've been heads down with them for 3 years right now. We have fully automated frac and these remote dispersed, geographically dispersed manufacturing plants in the worst places with communication. We've given them all the functionality of IT through our infrastructure, and we've been able to build 65 co-pilots to assist them in their automation, in their positions. And we're able to take those humans and the engineers and move them to the office. And then we're able to take the 24/7 business and move it more towards 8 to 5. What am I seeking? I'm really looking for people that want to take and move some of the stuff that's working currently in the energy space and apply it to your OEMs, apply it to your manufacturing, look at the different use cases. One of the things that we're super strong in is being able to pull in disparate data sets. So we look at maintenance data against production data, that data against weather data. You need to bring in computer vision data against all of those things. How can I get new insights across those data sets? If you're looking for that kind of thing, we're the right candidate for you. If you're looking to close the loop rather than tell a human about it, we're the right thing. We can drive actionable insights from our software. If you're looking for a hybrid edge to cloud infrastructure that's easy to use, that works currently with your hyperscalers like Google, Azure, and AWS, we're the right candidate for you. Additionally, if you're looking to release your R&D on the shelf and be able to get it out to the field quickly and scale it across your systems, Kelvin's your right software. Thank you for your time.
Awesome. Thank you. Thank you so much, Chad. All right, opening up the floor for Q&A.
Not a major question, but where are you based out of again?
We're based out of Silicon Valley. We have an office in Perth, Australia, Braga, Portugal, and then we had one here in Colorado where I'm at, but recently burned in the Boulder fire. So I haven't replaced that one yet.
Okay.
All right, Sarah, go right ahead.
Sure. Sorry to hear about the Boulder fire piece. Can you share a little bit around your roadmap? Like, what are you hearing from interesting customers or potential users that could further build upon the product you're talking about right now?
So the product is pretty well wide open, and it's a very easy tool set to use. And technically, I'll go way deep. So I try to stay up, but we have SDKs that make it really easy for people to take that R&D from places where they're already at and be able to put it into our system and be able to quickly ramp that through the system. Things that we're hearing about is with Halliburton, it went from one application that they needed to deploy across 50 different assets that are moving across the United States at any time. And they wanted to be able to update things. And so we were able to update as many times as we want the software that's running at that edge. And so we've been able to go from one application to 60 and from 4 people to 200 on the platform, building a way to fully automate this process. So we've been able to streamline that. So looking at it from other customers, I use the analogy of chess, and chess has been one of those things where it's been in the news recently around AI augmenting humans, right? And this guy actually cheated, but one of the things that we found in Australia that's just going over super well is our co-pilot. The framework of it is it looks back at the decisions that you made for 60 days. It looks at the assets around it, and it makes a suggestion back to the expert to what to do. That expert retrains the model by going yes or no. And that essentially the human is getting the buy-in to the AI that way because they're able to train it and build trust. And ultimately they can put it on autopilot. This framework has saved 95% of the engineering time in this specific field in Australia, all the while making them about 15 grand extra a day.
Thank you for that. Have you guys thought at all around a lot of the open source activity that's been going on for large language models and how to incorporate or build upon that for this application to really accelerate?
We actually have R&D looking at how we can do that with our software. Yes. So I think that the thing is we're so open and flexible. That is super easy. We're all API driven. So it's very rudimentary for us to tie in their API.
Cool. Thank you.
Yes, ma'am.
Perfect. Perfect. We have time for one more question. All right. If there's no more question, thank you so much, Chad. Feel free to leave your contact information in the chat. Really good presentation. And with that, we'll move on to Shay Harnoy with Edgy Bees.
Hi, everybody. Can you see my screen okay? All right. My name's Shai. Nice to see you. My name's Shai Harnoy. I'm here in sunny Boulder, Colorado. I want to talk to you about kind of what we're seeing in the space sector and how we're working to make an impact on the physical world. So we've all gotten used to scenes like this. Rockets landing like it was nothing. I remember my heart fluttering the first time that they stuck the landing. This has become a routine thing on a weekly basis. What are they doing up there? They're launching these guys. They're launching thousands of satellites. And what we're seeing today is that the Earth observation market has over 1,000 satellites currently in orbit, largely driven by commercial satellite launches. But it's not about how many satellites you get up there, or how many rockets you launch. It's about what you do with the data. So at Edgy Bees, we work with all that data, all that space data, all that overhead data that's collected from UASs around the world. And we improve its accuracy to make it usable, such that you can go from the image on the left, which is a flood scene, to the image on the right, where you can now augment it with AR, incorporating foundational data, intelligence reports, and actually make it actionable. So here's the problem. There's more and more aerial and satellite imagery collected than ever before. The opportunities to take these different data sets that are each good for different applications and to combine them, to make sense of them, to leverage AI and ML against large data stacks to extract insights. Unfortunately, these data are in different formats, different resolutions, different oscillator and collection patterns, but also different accuracies. This hurts you. It prevents comparisons over time. It results in incorrect conclusions about trends and change. And if you're trying to make use of the data in real time, there's no real-time context for these full motion video. Our vision is to be the platform for data interoperability, allowing all these small sats, optical Earth observation satellites, synthetic aperture radar, vectors, UAS imagery to all sing together. Maybe that's a little bit dramatic, right? But to harmonize and make the data sing. We operate in the cloud, on-prem, and in air-gapped environments. So let's go step by step at the bottom here. This is a standard workflow shown for the US government. We want to be where we can correct commercial satellite players, and we are just finished a POC with one of the major ones. We want to be there on the ingest to allow this data to come together. We want to be there on the analysis side, as well as the dissemination side. And I'll talk about traction across the board. By bringing together these data sets, by improving the accuracy, you can now have a more coherent picture. You can provide context and you can have rapid decision making. So for example, here, because you were able to align that satellite image to a reference layer, you can also drop in vectors, intelligence information, and augment the data. Why now? Why now? In May of 2022, so just last year, the NRO, the National Reconnaissance Office, awarded the world's single largest contract for commercial data purchases, with close to $6 billion allocated to commercial data buys over the next 5 years, awarded to three companies, Maxar, Planet, and Black Sky. Never before has this much data from different sensors been needed to be integrated together. We're seeing hundreds of terabytes a day being collected. And the space companies, the 1,694 space companies around the world, have raised over $253 billion. Now, this is why now. So what does Edgy Bees do? we make the data sing. We take in FMV data, we take in satellite data, we use our own reference layer or your own supplied reference layer, and we make it all consistent. And we're seeing use cases across infrastructure, military, environment and agriculture, law enforcement, humanitarian. This affects change detection, conflation of data sets, 3D modeling, GPS denied navigation, which we can get into, CAT analysis, meaning catastrophe analysis on the insurance sector, basically making this data useful, usable, and reliable. So to date, we've had about $12 million in government contracts, largely driven by AppStock and SOCOM. We have a robust security pipeline, as well as we're seeing a lot of the cloud players wanting to leverage their geospatial data holdings to bring people into their environment. We're seeing growing demand from data providers working with the commercial players, both on the SAR as well as optical side. A little bit about us. I'm an alumnus of Maxar. I was at Maxar for 6 or 7 years, where they acquired my company in 2013, Tomnod, that did analysis of satellite imagery. I went on to become an executive at Maxar, leading their entire AI effort. If you've ever heard of GBDX, that was what I was running, as well as Enhanced View web hosting service. So all the dissemination that Maxar does. I left Maxar to join Uber, where I was responsible for detecting and fixing map errors in real time and leading the group that does that, that builds the technology to do that. And then most recently, I was at Spire, the small sat manufacturer and operator Spire, leading one of their business units. So we're currently raising. We just had our first close at the end of December, raising 5 to 8 million in our A2 financing. The big use of proceeds is going to be on go-to-market. We're committed to the US market in particular. So beefing up on sales. We're getting our FCL, our facilities clearance in the next, actually next week. I'm going to be in DC for some pretty important meetings. And continuing to integrate with distribution partners. Thank you for listening.
Perfect. Thank you so much, Shai. That was fantastic. We'll have the questions in the order of the hands raised. So I'll open up the floor with that. Corey, go ahead.
Hey, sir. I've kind of tracked Edgy Bees as y'all have continued to grow with SOCOM and some of the stuff that you've worked on for the unmanned system side. But I also know that the DoD has invested a tremendous amount of dollars into your machine learning algorithms through what was known as Task Force Maven that the NGA has now taken over. And obviously you have competitors like Palantir and others in this world. What differentiates you from those other entities that are doing this and have the market share today?
Oh, Corey, I want to sit down with you for like an hour and a half to talk about this and about the current state of AI, because I lived it and I am living it. I aim to be the pipes that enable this stuff. I will never build the world's best single algorithm to detect that one object you care about the most today, in the region you care about, with the data set you have access to. That is a really hard value proposition, and we're seeing so many AI companies get pulled in the way of project-based services. I want to build the infrastructure. So you're talking about NGA and Project Maven. They're receiving FMV feeds from around the world and trying to create an ecosystem of algorithms of cutting-edge companies to make sense of that data. I want to be there to be the alignment layer. I want to bring that data together to make it usable, to make it indexable, to make it catalogable, to make it such that people can extract and leverage those insights. So you're absolutely right. We'll see what happens with the recompete now that it's going to NGA, right? But we've had many conversations in the sector specifically about that program, wanting to have an advantage by making the data sing and helping it harmonize.
Excellent. Thank you. I'll follow up with you.
I'm looking forward to that.
Cool. Quick question from my side. Actually, before I get to that, let's circle up after. I've definitely chatted with your team over the years, maybe last year and a half-ish. But let's circle up from a DIU position. Question for you here, though, is around that commercial piece. You said, hey, look, we're going to fundraise and we're going to go to market in a more concerted way in the private sector. Can you help me understand kind of what approaches go to market? What are the top targets there?
Yeah, no, absolutely. So I think that there's a couple of things. Some of the things we go direct. And so on a lot of our USG customers, we're going direct. We're building relationships, increasing intimacy. We just got installed on one of the classified networks of the Air Force. That was a big stepping stone in terms of getting installed and the certifications to allow that to happen. That was a really big deal. That happened 2 weeks ago.
What network is that?
Yes, SoftNet S, so SIPR. And the FCL is obviously going to help with a lot of that traction that we're hopefully getting by the end of the quarter. So on a lot of these government customers, we're continuing to increase our intimacy directly. That's why we're getting the FCL. On a lot of our international MOD clients, it's fragmented, it's difficult. You need local people on the ground. And so we're forming relationships with some pretty strong distribution partners who already have a footprint in each of these places. And sometimes we bring just the alignment module, the georegistration module that plugs into their UI. Other times they want more end-to-end services. So including our UI for AR that pulls in the AR layer foundational data. I call it a little bit like collaborative mission editing is what sticks out to me. Like an analyst on the network can drop a pin and have the pilot seeing it in real time, showing up on their screen where they're seeing the field of view of the aircraft. As they said, I love the SOCOM folks because they don't mince words. Like, oh, that's hot. That was the feedback, right? About that.
What about in the private sector though? What use cases?
Yeah,
we're gonna go after there.
So in particular on law enforcement and emergency response, it's really fragmented and challenging to go to market. So there's a couple of partners that sell specifically to public safety and first responders. And so leveraging them for distribution. On the state and local government and insurance, it's leveraging larger GIS distribution partners. You can imagine who they are. They didn't give me authority to put their logos on the slide, but those are the folks that I think have really good intimacy in those markets. I'm okay giving up points of margin to increase the rate of adoption and distribution. In general, right? Like you don't have to have it all. Like you actually want good partnerships and relationships.
Yes, you do. Thank you so much.
Thank you, sir.
Perfect. We have time for one more question. All right. If there's no more questions, thank you so much, Shai. That was a great presentation. With that, we conclude the showcase. Thank you so much. I'm sorry we ended a couple minutes late, but we appreciate everyone who hung on with us and stayed on, and we appreciate everyone's participation. Thank you to all of the companies that presented and all of the panelists that joined us, and feel free to follow up with us if you want to be connected on one side or another. We're always happy to try to make the connections, and stay tuned. Our next showcase is going to be IoT, Edge, Cloud, and Cyber, which should be a lot of fun. So stay tuned for that. Looking forward, and have a good rest of your day, everyone.
Thanks. Have a good one.
Have a good one. Thank you, Rich, for taking the time. We really do appreciate it.
Yeah, thanks, Asher. I really appreciate the invite, man. This was pretty fun. So hopefully I can link some people up with the right folks. Have a good night, man.
Good. That's the goal. Thank you.